Okay, so this is a walkthrough of the June 2023 paper 1. If you want to have a go at the paper yourself, I'll link it in the description. If you want to do any exam conditions, remember you have 2 hours and you're allowed access to the formula booklet, which I'll link in the description as well. Okay, so for question 1, we need to find the integral of x to the power of a half multiplied by 2x minus 5 over 3, and writing each term in its simplest form, and this is worth 4 marks. Now, if you don't know, I've made videos on all of the Edexcel A-level maths content, and any questions that are relevant to any particular content, I will link the video in which it's relevant to in the description. So in this particular case, this is just year 1 integration. So I'll link the video on year 1 integration that I made in the description. The reason that this is just year 1 integration is because in the numerator here we have this x to the power of a half multiplied by 2x minus 5. So what we can do is we can expand this bracket. So we can say that this is the integral of, okay, so we have x to the power of a half multiplied by 2x. Now remember, 2x is actually 2x to the power of 1. And remember your indices laws. If you have two powers multiplied together, so x to the power of a multiplied by x to the power of b, you add the powers. So this is equal to x to the power of a plus b. So therefore, in this instance, x to the power of a half multiplied by 2x to the power of 1 is going to be 2x to the power of 1 plus a half, which is 3 over 2. And then we've got x to the power of a half multiplied by minus 5, which is just going to be minus 5x to the power of a half. And all of this is going to be over 3, like this here. And what's nice about this is here we have two terms in the numerator and one term in the denominator. So what we can do is we can split this up and individually divide these two terms by the 3 in the denominator. So we can split this up and write this as the integral of 2 over 3 x to the power of 3 over 2 minus 5 over 3 x to the power of half, like this here, and then dx. And now what we can do is integrate these two terms individually in order to get an answer, and this is just year 1 integration. So if we start with the 2 over 3 x to the power of 3 over 2, so this is going to be equal to 2 over 3 multiplied by, and then if we integrate x to the power of 3 over 2, so remember this power here is going to go up by 1, so it's going to go up to 5 over 2, and we need to divide by 5 over 2, so it's going to be 2 over 5 x to the power of 5 over 2, like this here. And then it's going to be minus 5 over 3 multiplied by, and then we're going to integrate this x to the power of a half. So this half power here goes up to 3 over 2, so we're going to divide by this. It's going to be 2 over 3, and then x to the power of, that's going to be to the power of 3 over 2, like this here. Remember to include the plus c on the end, and then this is going to be equal to, if we simplify this, so this 2 over 3 multiplied by 2 over 5, 2 times 2 is 4 and 3 times 5 is 15, so this is going to be 4 over 15 x to the power of 5 over 2 minus, and then we've got these two fractions multiplied together. 5 times 2 is 10 and 3 times 3 is 9, so this is going to be 10 over 9 x to the power of 3 over 2, and then again remember this plus c on the end, and then that's the final answer. So in order to get all the marks here, you get 1 mark for showing that when you expand this bracket here you get an x to the power of 3 over 2 term and an x to the power of a half term. You get another mark for getting the coefficients right here, the 2 over 3 and 5 over 3. You get another mark for integrating in order to show you get the x to the power of 5 over 2 and x to the power of 3 over 2, and then you get another mark for getting this final answer here. You need to include the plus c here in order to get the 4th mark. Okay, so for question 2, we're told that f of x is equal to 4x cubed plus 5x squared minus 10x plus 4a, where a is a positive constant. And given that x minus a is a factor of f of x, we need to show that this here is true, and it's worth 2 marks, okay? And the key to figuring out this question is this line here. Now this line is to do with the factor theorem that we talked about in year 1 of chapter 7. If x minus a is a factor of f of x, what this means is that f of a is equal to 0. Another way of saying this is, so this f of x here, if we sub in for x, if we sub in x is equal to a, this function here will be equal to 0. And what's useful about this is if we sub in x is equal to a into this function and equal it to 0, we can rearrange it in order to get this equation here. Okay, so if we do this, so it's going to be f of a, so f of a is equal to 4, and then here we have x cubed, but rather than having x here, we're now going to have a, so this is going to be a cubed, like this here, because remember we're subbing in x is equal to a, and then it's going to be plus 5, and then instead of x, it's going to be a, so it's going to be a squared minus 10a, like this here for x, and then this is still going to be plus 4a on the end. And this here is equal to 0. So we have this equation here, and we need to get it into this format. So we can do some simplifying. So we're still going to have this 4a cubed plus 5a squared here, and here we have this minus 10a plus 4a, which can be simplified to minus 6a, and this is equal to 0. And you can see in this final answer here, we need to factorize out a, and we have a common in all of these terms. So if we factorize out a, it's going to be a, and then if you factorize a out here, it's going to be 4a squared plus 5a minus 6, and this is equal to 0, and this here is what's required. So we've got the final answer. In order to get the 2 marks here, you get 1 mark for factorizing out the a here and showing that this here is some form of polynomial. This is 1 mark, and then you get the second mark for showing that this here is the 4a squared plus 5a minus 6. Okay, and then for the first part of B, we need to find the value of A. Okay, so essentially what we just need to do is solve this equation that we made in part A and find the value of A. So it's this equation here. And as we have the A 4A squared plus 5A minus 6 is equal to 0, that means that we have 2 possibilities. Either A is equal to 0, or 4A squared plus 5A minus 6 is equal to 0. Now, as in the question, we are told that a is a positive constant. 0 is not a positive constant, so therefore this is not the value of a. So therefore, it's going to be just this solution here, this 4a squared plus 5a minus 6 is equal to 0. So we need to solve this quadratic here. There's loads of ways that we can solve quadratics. We can factorize it, we can use completing the square, or we can use the quadratic formula. I'm just going to use the quadratic formula. So remember, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a, where a is 4, b is 5, and c is minus 6. So therefore, if we sub these values in, we're going to get that a is equal to minus b, so minus 5, plus or minus the square root of b squared, so 5 squared minus 4a, so this is 4c, which is minus 6, and this is over 2a, so this is 2 times 4. And if you put this here into your calculator, you get out a value of either 3 over 4 or minus 2. Now, as we're told that a is a positive constant, it can't be minus 2. So a cannot be equal to minus 2 because it's negative. So that means the value of a has to be where a is equal to 3 over 4. This part here is only worth 1 mark. You get the mark for showing that a is equal to 3 over 4. So this is the final answer. Okay, and then for the second part of B, we need to use algebra to find the exact solutions of the equation f of x is equal to 3. Now remember, f of x is this function up here, and as we figured out that a is equal to 3 over 4, we can sub this in, so we can rewrite f of x as 4x cubed plus 5x squared minus 10x plus 4. And then instead of a here, we can sub in 3 over 4 like this here. And the question is asking us to find the exact solutions of the equation where f of x is equal to 3. So this here is equal to 3, and we need to solve this equation here, okay? So we can do some simplifying. So we have 4x cubed plus 5x squared minus 10x plus, and then we have 4 multiplied by 3 over 4 here. This 4 will cancel out. This 4 denominator just leave us with 3, and this is equal to 3. And then move this 3 to the other side, and this will cancel out this plus 3 here, which just leave us with 4x cubed plus 5x squared minus 10x is equal to 0, okay? Now we have x in all of the terms here, so we can factorize this out. So it's going to be x 4x squared plus 5x minus 10 is equal to 0. So that means there are two possibilities here. Either x is equal to 0 or 4x squared plus 5x minus 10 is equal to 0. So this here is one solution, that x is equal to 0. Remember, this is not, don't get confused with the thing with a here before, where a has to be a positive constant. This is not the case for x. X doesn't have to be a positive constant, so x can be equal to 0. This is a valid solution. So now we need to solve this here. 4x squared plus 5x minus 10 is equal to 0. For this, remember, it says that we need the exact solutions. So we're going to use the quadratic formula. Remember, it's this here. So a is 4, b is 5, and c is minus 10. So therefore, x here is equal to minus b, so minus 5, plus or minus the square root of b squared, so 5 squared, minus 4a, so 4c, which is minus 10, and all of this is over 2a, so 2 times 4. We can do some simplifying here, so we have a minus 5 plus or minus, and then if you put this here, this 5 squared minus 4 times minus 10 into a calculator, you get out 185. So this is going to be the square root of 185, and this is the simplest way that you can write this surd. And all of this is over 2 times 4, which is 8. So x is equal to minus 5 plus or minus the square root of 185 over 8. So that means there are 3 possible solutions for x. Either x is equal to 0, as we said up here, or x is equal to minus 5 plus the square root of 185 over 8, or x is equal to minus 5 minus the square root of 185 over 8. And this here is the final answer. These are the 3 exact solutions for x. To get the 3 marks here, you get the first one for finding this equation here, you get the second one for showing that x can be equal to 0, and you get the third mark for showing that x can be equal to these 2 solutions here. Okay, so for question 3, we're told relative to a fixed origin O, the point A has position vector 5i plus 3j plus 2k, and the point B has position vector 2i plus 4j plus ak, where a is a positive integer. For part A, which is worth 1 mark, we need to show the magnitude of the vector OA is equal to root 38. So this is a 3D vectors question. Now remember how position vectors work. If we talk about the position vector of point A, this is the vector OA, and if we talk about the position vector of point B, this is the vector OB. So we need to show the magnitude of OA, which is this vector here, is equal to root 38. Remember how to find the magnitude of a 3D vector. These 3 numbers here, 5, 3, and 2, we square them, add them together, and then just take the square root, and this is the magnitude. So therefore, the magnitude of OA is equal to the square root of 5 squared plus 3 squared plus 2 squared. And if you put this into a calculator, this is equal to root 38, which is what's required. So this is a 1 mark question, and you get it for this. Okay, and then for part B, we need to find the smallest value of A for which the magnitude of OB is bigger than the magnitude of OA, and this is worth 2 marks. Now, in part A, we figured out the magnitude of OA is equal to root 38. So to figure out the magnitude of OB, which is this vector here, so remember the magnitude is these three numbers together, squared, added together, and then the square root of this. So the magnitude of OB is equal to the square roots of 2 squared plus 4 squared plus a squared. Now we can simplify this because 2 squared is 4, and 4 squared is 16, and 4 plus 16 is 20. So we can rewrite this as 20 plus a squared. So this is the magnitude of OB. Now we have this inequality here that the magnitude of OB is bigger than the magnitude of OA, and as we know both these magnitudes, we can set up this inequality by subbing in these values. So we can say that the square root of 20 plus a squared is bigger than the magnitude of OA, which is root 38. And what we can do with this is rearrange this inequality in order to get an inequality for A, and this will help us find the smallest value of A, okay? So this here, firstly, if we square both sides to get rid of the square roots, so we get 20 plus A squared is bigger than 38, and then move the 20 to the other side, so we get that A squared is bigger than 38 minus 20, which is equal to 18, and then square root both sides, so we get that A is bigger than the square root of 18. Now we need to find the smallest value of A, but we are told that A is a positive integer. Now, root 18, if you put root 18 into your calculator, it's equal to 4.24. So the smallest value of A is not going to be 4.24 because this is not a positive integer. We need A to be a positive integer. If we sub in this 4.24, we get that A is bigger than 4.24. So we need to find the smallest positive integer that is bigger than 4.24, which is going to be 5. So therefore here, A is equal to 5. This is the smallest value of A, given that A is a positive integer, where the magnitude of OB is bigger than the magnitude of OA. This is worth 2 marks. The 2 marks, the first one comes from getting this here, that the magnitude of OB is equal to this, and the second one is figuring out that A is equal to 5. Okay, so here's question 4 here. If you're having a go at these questions yourself at the same time, I've given you the formula here for the small angle approximation of cos, because this is given to you in the formula booklet, so you have access to it in the exam. So for this question, we're told that the curve C has equation y is equal to f of x, and we're given 3 bullet points. We're told that f dash of x is equal to 2x plus a half cos x. We're told that the curve has a stationary point with x coordinate alpha, and we're told that alpha is small. For part A, we need to use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places, and this is worth 3 marks. So this is obviously a small angle approximation question, which we did a video on. Now there's some key info here that you need to realise. So firstly, we're told that the curve has a stationary point. Now remember, stationary points exist where f dash of x, so the derivative, is equal to 0. And as we're told that this stationary point exists where the x coordinate is alpha, therefore f dash of alpha is equal to 0. Okay, so we can use the small angle approximations here because we're told that alpha is small. So as we know that f dash of alpha is equal to 0, what we can do is we can sub alpha into this function here, get f dash of alpha, and equal this to 0, and then we've got an equation, and then we can find the value of alpha. So if we do this, so it's going to be f dash of alpha is equal to 2 and then x, so it's going to be alpha and then plus half cos, and then instead of x is going to be alpha here, and this is a stationary point, so therefore this is going to be equal to 0. So we have this equation here that we can use in order to estimate the value of alpha. It's going to be an estimate because we're going to use small angle approximations here for cos alpha. Now here we it's told in the formula booklet that cos theta is equivalent to or is an estimate approximately equal to 1 minus theta squared over 2 when theta is small. So therefore, if alpha is small here, we can say that cos alpha is approximately equal to 1 minus alpha squared over 2. So we can sub this in and say that 2 alpha plus a half, and then we're going to sub out the cos alpha here for the 1 minus alpha squared over 2, and this is equal to 0, and therefore we're going to find the value of alpha with this equation. So let's do some simplifying. So we have 2 alpha plus, and then we're going to expand this bracket here, so a half times 1 is equal to a half, and then a half times minus alpha squared over 2 is going to be minus alpha squared over 4, and this is equal to 0. To get rid of these denominators, we're going to multiply everything here through by 4. So this 2 alpha is going to become 8 alpha, this half here is going to become 2, and then this denominator here, this 4, will cancel out and leave us with minus alpha squared like this here, and this is equal to 0. Now there's no easy way to factorize this, so we're going to use the quadratic formula. So as we talked about before, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a, where a here, it might be easier if we rewrite this kind of in the simple quadratic way as this minus alpha squared plus 8 alpha plus 2 is equal to 0. So a is equal to minus 1, b is equal to 8, and c is equal to 2. So therefore, if we do this, it's going to be alpha is equal to minus b, so b is 8, so it's going to be minus 8 plus or minus the square root of b squared, so 8 squared, minus 4a, so a is minus 1, and then c, which is 2, and all of this is over 2a, so it's over 2 times minus 1. Now if you look at the question, it wants the value of alpha to 3 decimal places. Okay, so this here, if you put this into your calculator, you get that alpha is equal to 2 values. It's equal to either minus 0.243 or 8.243. Now if you look at the question, it wants us to estimate the value of alpha. So there's only one value of alpha. The problem is here we've got 2 values. So how do we know which one it is? Well, we're told a key piece of information, of course. Because we're using small angle approximations, we can only use this because alpha is small. If we look at our 2 values here, 8.243 is not small. So therefore alpha cannot be equal to 8.243, so therefore alpha has to be equal to the other value, which is minus 0.243, which is small. So this here is the final answer. In terms of the marks here, so this is worth 3 marks. You get 1 mark for making this substitution here for cos alpha. You get another mark for getting it into this format here, and then you get another mark for figuring out the answer is this here. Okay, so for part B, we're told that the point P, which is 0, 3, lies on C, and we need to find the equation of the tangent to the curve at this point P, giving our answer in the form y is equal to mx plus c, and this is worth 2 marks. So this is to do with finding the equation of a tangent, which is year 1 differentiation. Okay, so remember, a tangent is a straight line, so the equation of a straight line is y minus y1 is equal to mx minus x1. Okay, so in order to get the equation of a straight line like the equation of a tangent, we need 2 things. We need a point on the line, this is the x1 y1, and we need the gradient of the line, this is the m here. Okay, well, we know a point on the tangent because we're told that the tangent is to the curve at the point P. We know this P is 0, 3. So therefore the tangent passes through this point P, which is 0, 3. So we have this. We just need to find the gradient of the tangent. Well, we can do this because we are told that the tangent is at the point P, which is 0, 3. So therefore here x is equal to 0. Now remember, one of the features of a tangent is the gradient of the tangent is going to be the same as the gradient of the curve at that particular point at where the tangent is. So this here is this point P. And as we know f dash of x, we know the derivative. What we can do is we can sub in x is equal to 0 into this, find out what the derivative is. This is going to be the gradient of the curve at this point where x is equal to 0, and this is also going to be the gradient of the tangent, which we can sub into this equation here. So we're going to sub in x is equal to 0 into f dash of x, so therefore this is going to be f dash of 0 is equal to, so it's 2x, it's going to be 2, 0 plus a half cos 0. Okay, so we can do some simplifying here. So 2 times 0, this will just go away, and then half cos 0. Cos 0 is 1, so therefore it's going to be half times 1, which is a half. So therefore f dash of 0 is equal to a half. So this is the gradient of the curve at the point P. So this is also going to be the gradient of the tangent. Okay, so therefore we can use this equation here for the equation of the tangent, the equation of the straight line, using the point here P, which is 0, 3. So therefore it's going to be y minus y1. Now the point P is 0, 3, so y1 is equal to 3, so it's going to be y minus 3 is equal to m, which we figured out is a half, and then it's going to be x minus x1, so the x coordinate is 0, so it's going to be x minus 0, so therefore it's just going to be x, so this is just going to be half x. We need to give our answer in the form y is equal to mx plus c, so move this minus 3 to the other side, so we get that y is equal to a half x plus 3, and this here is the final answer. This is the equation of the tangent in the form y is equal to mx plus c. This question is worth 2 marks. You get the 2 marks for, so you get 1 mark for figuring out f dash of 0 here, or plugging in the value of x is equal to 0, and then you get the other mark for figuring out this equation here. Okay, so here's question 5. I've given you the formula here for the trapezium rule because it's given to you in the formula booklet. So we're told about the curve of equation y is equal to f of x, and we're told about this table that shows corresponding values of x and y for this curve. So we have x values from 3 to 4, and in this table we can see that 4x is equal to 3, y is equal to a, and 4x is equal to 3.4, y is equal to B, and A and B are constants. And the trapezium rule is used with this table to find an approximate area under the curve between x is equal to 3 and x is equal to 4. And this area that they found using the trapezium rule is 17.59. And we need to show that a plus 2b is equal to 51. So this is obviously a trapezium rule question, which we did a video on. So what we're going to do is we're going to use this formula here. So we're going to find the h value, and we're going to use the y values in this table. There are 1, 2, 3, 4, 5, 6 coordinates here. So it's going to go up to y6. So here kind of n is equal to 6, and then if we sub these values in, this is going to be equal to 17.59, and then we need to rearrange in order to show this here is true. Okay, so firstly, what is h? Now remember, h is the width of the trapeziums, okay, and it's also the difference between the x values. And on this table you can see that as we go from 3 to 3.2, 3.2 to 3.4, 3.2 to 3.6, they all have a difference of 0.2. So therefore, h is equal to 0.2. Okay, so that's what we're going to sub in for h, and then these y values here are just these y values in the table. Okay, so if we do this, so it's going to be half, and then we're going to sub in h, which is 0.2, Okay, so here we have y0 and yn, which remember goes up to 6 here. So y0 is a, and the final y value is 13.5. So here it's going to be a plus 13.5, and then it's plus 2. So it's plus 2, and then we've got all the other y values here. So this is going to be 16.8 plus b plus 20.2 plus 18.7, and then remember all of this is times by 2, and all of this is also multiplied by this at the front here, this half 0.2. So this here is all the values subbed into this equation here, and all of this is equal to 17.59 as we're told in the question. And now we need to rearrange this to show that a plus 2b is equal to 51. Okay, so we can do some simplifying here. So firstly we have a half times 0.2, which is equal to 0.1. Okay, so we still have this a plus 13.5 plus 2. Now here we have this 16.8 plus 20.2 plus 18.7, which if you put this into a calculator, it's going to be 55.7, and then we've still got this b here, so this is still going to be plus b, and then this is equal still to the 17.59. We can do some more simplifying here, so it's 0.1 a plus 13.5 plus, and then we're going to expand this bracket here, so 2 times 55.7 is equal to 111.4, and then 2 times b here is plus 2b, and this is still equal to 17.59. If we do some more simplifying here, we have this 0.1 at the front, we have a, and then we have this 2b here, so a plus 2b, and then we have this 13.5 plus 111.4, which again if you put it into your calculator is equal to 124.9, and this is equal to 17.59. Now if you look at the part A, we have this a plus 2b, which is what we have here, so that's good. We have this 0.1 at the start here, so let's divide here both sides by 0.1. So on this side, if we get rid of this, it will be a plus 2b plus 124.9 is equal to, and then 17.59 divided by 0.1 is equal to 175.9, and then move this 124.9 onto the other side, so we get the a plus 2b is equal, and if you put this into your calculator, 175.9 minus 124.9, you get out 51, and this a plus 2b is equal to 51 is what's required here for part A. So this is worth 3 marks. You get the 3 marks, so you get 1 mark for realizing that h is equal to 0.2. You get another mark for setting up this equation here, and then you get the final mark for showing that a plus 2b is equal to 51. Okay, and then for part B, we're told that given also that the sum of all the y values in the table is 97.2, we need to find the value of A and the value of B for 3 marks. Okay, so what this line is saying here is the sum of all of these y values here in the table is equal to 97.2. So if we put this into an equation, it's going to be A plus 16.8 plus b plus 20.2 plus 18.7 plus 13.5. So these are all the y values, and all of these added together is equal to 97.2. Okay, so we can simplify this. So here we have this a plus b, so it's going to be a plus b plus, and then 16.8 plus 20.2 plus 18.7 plus 13.5. If you put it into your calculator, it's equal to 69.2, and this is equal to 97.2. So therefore a plus b is equal to, if you move this 69.2 onto the other side, you get that a plus b is equal to 28. And what's useful about this is now we have a pair of simultaneous equations. We have this a plus b is equal to 28, and we have this a plus 2b is equal to 51 that we figured out in part A. So therefore we can figure out the values of a and b from this here. Now there's loads of ways that we can solve simultaneous equations. The easiest way to do this one, in my opinion, is elimination. So here we have this a plus 2b is equal to 51, and here if we take away this a plus b is equal to 28. So a minus a will just cancel out, and then 2b minus b is going to be equal to b, and then 51 minus 28 is equal to 23. So b is equal to 23. So therefore we can figure out the value of a by just subbing this into here. So it's going to be a plus b, which is 23, is equal to 28. Move the 23 onto the other side, so a is equal to 5. So a is equal to 5 and b is equal to 23, and this is the final answer. In order to get the marks here, you have to get to this a plus b is equal to 28 for 1 mark, and then try and solve for a and b. You get 1 mark for getting b is equal to 23, and you get 1 mark for a is equal to 5. Okay, so for question 6, we're told that a is equal to log base 2 of x and b is equal to log base 2 of x plus 8. And we need to express in terms of a and or b. For part A, log base 2 of root x for 1 mark. Okay, so this question is to do with laws of logarithms. So firstly, for all of these questions, A, B and C, you can essentially avoid the base 2 part. I'm still going to say it when I'm writing it down, and you still need to write it down in your method, but because all of them are log base 2, it doesn't really make a difference. I think they've just added it to make it more complicated. Okay, it's just a basic log question. Okay, so when you're doing A, B and C, I think the best thing here is to compare whatever you have here to either A or B. And for part A, you can see that log base 2 of root x is very similar to log base 2 of x. The only difference is this root here. If you remember your laws of indices, root x, you can write it as x to the power of half. So therefore we can rewrite part A as log base 2 of x to the power of half. If you remember your laws of logs, when you have a power inside a log, you can bring it to the front of the log as a coefficient. So this here is equal to half log base 2 of x, and this log base 2 of x here is a, so we can sub this out and write this as half a. So this is the answer to part A, it's half a. Okay, so for part B, we have log base 2 of x squared plus 8x for 2 marks. Now let's compare it to A and B up here, and you can see that this is really similar to B here, this log base 2 of x squared plus 8x. You can see we have this x plus 8 in the brackets here, and here we have this x squared plus 8x. The only difference here is that everything is multiplied by x. So if we factorize out x from this, so we write this as log base 2 of, so if we factor out x from this x squared plus 8x, it becomes x plus 8, like this here. Okay, now what we can do from here, if you remember laws of logs, is if you have two things in a logarithm multiplied together, so this x multiplied by this x plus 8, you can split them up into two separate logs by adding them. So what we can do is we can rewrite this here as log base 2 of x plus log base 2 of x plus 8. Hopefully you can see why this is, because remember, when you add logs like this, it multiplies what's inside the logs. So this x plus 8 can be written as log x plus 8, like this here. And what's useful about this is a is equal to log base 2 of x, which is what we have here, and b is equal to log base 2 of x plus 8, which is what we have here. So therefore we can sub in a and b here and write this as a. So here the log base 2 of x is the a plus, and the log base 2 of x plus 8 is equal to B. So part B is equal to A plus B. In terms of the marks here, you get 1 mark for finding this here, and you get 1 mark for finding it as A plus B. Okay, and then for part C, we have log base 2 of 8 plus 64 over x. And this is for 3 marks. And this one is definitely the most difficult, okay? And you might need to play around with this one a bit before you get to the right method, okay? So the thing that's really awkward about this one here is inside the bracket, we have this 8 plus 64 over x, with this 64 over x and this x in the denominator. And this is quite difficult to work with. So this 8 plus 64 over x, one thing we could do to get rid of this x in the denominator is we could factorize out 1 over x from this here. So if we do this, so if we start with factorizing out 1 over x from 8 here, this would be 8 x, because if you think about it, if you do 8x multiplied by 1 over x, this x will cancel out with this x denominator to just leave us with 8. So if you factorize out 1 over x from 8 is 8x, and then this is plus, and then if you factorize out 1 over x from 64 over x, it's going to be 64 like this here. So therefore we can rewrite this log here as log base 2 of 1 over x multiplied by 8x plus 64. Okay, now remember your laws of logs as we talked about. If you have two things that inside a log multiplied together, like 1 over x and 8x plus 64, you can split up these logs by adding them. So we can rewrite this here as log base 2 of 1 over x plus log base 2 of 8x plus 64. Okay, so we can do some simplifying here. So this log base 2 of 1 over x, remember that 1 over x is equal to x to the power of minus 1, if you remember your laws of logs. So therefore we can write this as log base 2 of x to the power of minus 1, and then this is plus this here, this log base 2 of 8x plus 64. Now if we compare this to b, so here we have log base 2 of 8x plus 64. You can see that inside the bracket x plus 8 and 8x plus 64 are actually very similar. The only difference is that this one here is multiplied by 8. So what we could do is we could factorize 8 out of this. So we could write this as log base 2 of 8, and then it would be x plus 8 like this here. So we have this x plus 8 like this here, okay? So we can do some further simplifying. So here, remember, we have this power of minus 1 here. When you have a power inside a log, it can come to the front as a coefficient. So we can write this as minus log base 2 of x, and then this is plus. So we have this 8 times this x plus 8. Remember, when you have two things inside a log that are multiplied together, you can split them up into two different logs by adding them. So this will be log base 2 of 8 plus log base 2 of x plus 8. Okay, so this is really useful to us, and the reason for this is, so here we have this minus log base 2 of x, and a is equal to log base 2 of x, so we can write this here as minus a. Okay, and then this is plus log base 2 of 8. Now remember what a log actually means. When we have a log base 2 of 8, so let's say that we don't know what log base 2 of 8 is, what this actually means is that, so we have base 2 here, so it's 2 to the power of something is equal to 8. Well, here this question mark is going to be 3, because 2 to the power of 3 is equal to 8. So therefore here log base 2 of 8 is equal to 3. You can also see this if you put it into your calculator. Log base 2 of 8 is equal to 3. And then this is plus log base 2 of x plus 8, and this is what b is. So therefore this here is b. So therefore the answer here is minus a plus 3 plus b, and this here is the final answer. To get the marks, you firstly have to realise this here. If you factorise out the 1 over x and you get this 8x plus 64, you get the second mark for getting this expression here, and then you get the third mark for getting this minus a plus 3 plus b. Okay, so for question 7, we're told that the function f is defined by f of x is equal to 3 plus the square root of x minus 2, and the domain is where x is bigger than 2. And for part A, we need to state the range of f. So this is to do with the functions video that we made back in year 1 of chapter 2, to do with domains and ranges. And the best way to approach this is if we start with the domain here, where x is bigger than 2. So if we look at the x minus 2 here inside the square root, if x is bigger than 2, that means that x minus 2 is going to be bigger than 0. I've just minus 2 from both sides here. So we have the square root of x minus 2. So the square root of x minus 2, if x minus 2 is bigger than 0, that means the square root of x minus 2 is also going to be bigger than 0. And then it's 3 plus this square root of x minus 2, so 3 plus the square root of x minus 2. So just add 3 to both sides, so this here is bigger than 3. So this is the 3 plus the square root of x minus 2 is bigger than 3. So therefore the range of f of x is bigger than 3. Okay, and then for part B, we need to find the inverse of f. So this is to do with the inverse and composite functions video that we made back in year 2 of chapter 2. If you remember how we find inverses, so we have here f of x is equal to 3 plus the square root of x minus 2. Okay, so what we're going to do is we're going to replace this f of x with a y. So we're going to say that y is equal to 3 plus the square root of x minus 2. And what we're going to do is we're going to switch around the y and the x. So what we're going to say is we're now going to say that x is equal to 3 plus the square root of y minus 2. And what we're going to do is rearrange in order to make y the subject, and this will give us the inverse. Okay, so if we do this, if we move this 3 to the other side, we get that x minus 3 is equal to the square root of y minus 2, and then square both sides, so we get x minus 3 squared is equal to y minus 2, and then add 2 to both sides, so we get the x minus 3 squared plus 2 is equal to y, and this here is the inverse. F of minus 1 of x, so the inverse of f of x is equal to x minus 3 squared plus 2. Now, one other thing you need to get all 3 marks for this question, when we talk about functions questions, one thing that's quite important when we're defining a function is we also need to include the domain with the function. You can see that they've done this here. So for f of x here, they've given the domain as x is bigger than 2. For later, when they define g of x, they give the domain where x is not equal to 3. So here we need to define the domain. And if you remember, a property of inverse functions compared to their non-inverse functions is the domain and the range swaps around. So the range of f of x will now be the domain of the inverse of f of x. And we figured out in part A that the range of f of x is where it's bigger than 3. So now this is the domain of the inverse. So therefore it's where x is bigger than 3, because this is the value domain. So in order to get all 3 marks here, you firstly have to do this approach where you switch around the X and Y, and then you need to get it into this format here, this X minus 3 squared plus 2, and to get the 3rd mark you need to say where X is bigger than 3. You might view this as quite harsh, and I guess I can see that argument of kind of you lose a mark if you don't say the domain here, even though they don't explicitly ask us to give the domain. But kind of with functions questions, when the question is specifically about functions, when you're defining a function, you kind of need to give the domain to fully define it. Okay, so for part C, we're told about the function g that is defined by g of x is equal to 15 over x minus 3, where x cannot be equal to 3. And for part C, we need to find gf of 6. So this is a composite functions question. Now, there are 2 ways that you can do this question. Kind of the longer way to do it is to find the composite function gf of x. If you remember how to do this, you kind of sub in f of x as x into g of x in order to get g f of x, and then once you've done that, sub in this x is equal to 6, and that will get you g f of 6. That's kind of the longer way of doing it. Actually, the shorter way you can do it is this g f of 6. What you can do is f of x is equal to 3 plus the square root of x minus 2. You can actually first find f of 6, so sub in x is equal to 6 into f of x, so it would be f of 6 is equal to, so it'd be 3 plus the square root, so it's x minus 2, so it'd be 6 minus 2, so this would be 6 minus 2 is 4, and then the square root of 4 is 2, and then 3 plus 2 is 5. So f of 6 is 5, and then this 5 here, you can sub this into g of x, and this would be gf of 6. So therefore, if you sub in this 5 into g of x, it would be g of 5 is equal to, so g of x is 15 over x minus 3, so this will be 15 over 5 minus 3. 5 minus 3 is 2, so it'd be 15 over 2. So g of 5 is equal to 15 over 2, and this is actually the answer to g f of 6 is equal to 15 over 2, and this is kind of the slightly shorter way of doing it. So in order to get the 2 marks here, the first way is kind of realizing this kind of subbing in method, like I've done here. If you show some evidence of this, you get 1 mark, and the second mark is to get this 15 over 2. Okay, and then for part D, we need to find the exact value of the constant a for which f of a squared plus 2 is equal to g of a, and this is worth 2 marks. Okay, so let's actually break down what this question is actually asking us. So f of a squared plus 2, what that means is we sub in x is equal to a squared plus 2 into f of x. So this here is going to become 3 plus and then the square root, and then instead of x, it's going to be a squared plus 2. Then we also have this minus 2 here, so it's going to be minus 2 like this here. And then g of a means we sub in x is equal to a into g of x, so this here is going to become 15 over a minus 3, and it's saying that these two are equal to each other and we need to find what a is. Okay, so if we write this out, it's going to be 3 plus the square root of a squared plus 2 minus 2 is equal to g of a, which is equal to a minus 3 under 15. We need to rearrange in order to find what a is. Okay, so firstly we have this plus 2 minus 2, and these two will cancel out to leave us with 3 plus the square root of a squared is equal to a minus 3 under 15. The square root of a squared is just equal to a, so this is 3 plus a is equal to a minus 3 under 15. So to get rid of this a minus 3 denominator here, we're going to multiply both sides here by a minus 3, so this will get rid of this denominator here. So on this side, this 3 plus a, I'm going to write it as a plus 3, and hopefully you'll see why in a moment. And then this is multiplied by this a minus 3, and this is equal to the numerator 15. Now this a plus 3, a minus 3, this is a difference of squares, so this is going to be equal to a squared minus 9, and this is equal to 15. Move the minus 9 onto the other side, so we get that a squared is equal to 24, and take the square root of both sides, so we get that a is equal to the square root of 24. We do need to worry about the plus or minus square root. However, you find out that if you try and use the negative square root, so the minus root 24, you find out that this equation here, this equation here doesn't work if you try and use this. So therefore, this isn't a valid answer. So a is equal to the positive root 24. If you simplify this, a is equal to, so root 24 is equal to 2 root 6. So this here is the answer. This is the exact value of the constant a, for which f of a squared plus 2 is equal to g of a, where g is equal to 2 root 6. To get the 2 marks here, you get the first mark for getting to this part here, and then you get the second mark for getting the answer. Okay, so for question A, we're given this diagram here, and it's meant to represent a stage. And in this diagram, there are 3 shapes. We're told about 2 congruent triangles that are here and here, and we're told that these are congruent. Remember, the word congruent means they're identical, and we're told that they are joined to a sector which is here. Okay, and we're given some information about these shapes. We're told the angle COE is equal to 2.3, so this is this angle here. We're told the arc length is equal to 27.6, so this is up here, and we're told that AOG, which is down here, is a straight line and it has a length of 15 meters. And for part A, we need to show that OC, so this is this line here, we need to show that this is equal to 12 meters and it's worth 2 marks. Okay, so this is a question about arc length and sector area that we talked about in the radians chapter back in year 2 of chapter 5. And if we look at the line OC that we need to find, you can see that this is the radius of the sector here. This is the radius, and what we know about this sector, we know the length of the arc up here, this is 27.6 meters, and we know the angle at the center here, it says 2.3 radians. If you recall the formula for arc length, it's L, which is the length of the arc, is equal to r, which is the radius, multiplied by theta, which is the angle at the center of the sector here. Well, we know what L is. This is the length of the arc, so L is equal to 27.6. R is this here that we need to find, this OC, so R is, we'll just call this R for now, and theta is this angle here at the center, which we know is 2.3 radians. So therefore what we can do is sub these values in order to find R and OC. So therefore it's going to be L, which is 27.6, is equal to R times theta. We know theta is 2.3, so this is going to be 2.3R. Then divide both sides by 2.3, so we get that R is equal to, when you put this into a calculator, is equal to 12. So R is equal to 12, and as R is OC, this means that OC is also equal to 12, and this is what we need to prove here. To get the 2 marks, you get the first mark for showing this formula here and plugging in the values, and you get the second mark for showing it's equal to 12. Okay, and then for part B, we need to show that the size of angle AOB is 0.421 radians correct to 3 decimal places. Okay, so angle AOB is this angle here, so we need to find this angle. Okay, and we can see that this is very close to this 2.3 radian angle here, that is COE, and we can also see that they both lie on this straight line here, AOG. In fact, we're told in the question that AOG is a straight line. Remember, one of the features of a straight line is that an angle on a straight line is 180 degrees. So that means that the angle AOG is equal to 180 degrees, or because we're working in radians, is equal to pi radians. Okay, so let's look at the angle AOG. Okay, so the angle AOG is made up of this angle AOB that we need to find. So the angle AOB, and for the sake of this question, let's call the angle AOB, let's call this theta. Okay, and then it's plus the angle here, this COE. So angle COE, and then this is plus this angle here as well, which is angle GOF. Okay, so if we look at all these angles, well, we know that AOG is pi radians, or 180 degrees, because we figured it out because it's on a straight line. So AOG is pi, and this is equal to AOB, which is the angle that we want, that we've called theta. So this is equal to theta plus COE, which we can see is this angle here in the sector, is this 2.3, and then it's plus this GOF, which is this angle here. Now, because we're told that these two triangles are congruent, they're identical, that means that this angle here is going to be the same as this angle here. They're both going to be theta. So therefore this angle is also going to be theta here, and therefore we've made this equation here, and we can rearrange it in order to find theta. Okay, so to simplify this, it's pi is equal to, and then group the theta plus theta together, so it's 2 theta is plus 2.3, like this here, and therefore it's going to be pi minus 2.3 is equal to 2 theta, and then divide both sides by 2, so we have pi minus 2.3 over 2 is equal to theta. If you put this into your calculator, this pi minus 2.3 over 2 to 3 decimal places, it gives out a value of 0.421. So 3 decimal places, which is what they want as the final answer. So therefore that's how you get the 0.421. To get the 2 marks here, you need to show evidence of this pi minus 2.3, and then you need to get the correct answer. Okay, and then for part C, we're told that the total length at the front of the stage, which is B, C, D, E, F, is 35 meters. And we need to use this information to find the total area of the stage, given your answers to the nearest square meter. And this is worth 6 marks, okay? So essentially what this question is just asking us is to find the area of this entire shape here. Now remember, this shape is made up of this sector here, and then it's made up of these two congruent triangles here. Okay, now to start off with, this information about the length of the front of the stage being 35 meters, we're going to ignore this for now. The easiest thing to do in this question, in my opinion, is to firstly figure out the area of the sector here. Now, if you recall back to year 2 of chapter 5, the area of a sector is equal to half times the radius squared multiplied by theta, where r is the radius of the sector and theta is the angle at the center of the sector. Okay, well, we can use this because we know that r is equal to the radius of the sector, which we figured out for A, OC, which is the radius, we figured it out as 12. So therefore R is equal to 12. And theta is the angle at the center of the sector, which we're told is 2.3. So therefore the area of the sector is equal to half times the radius, which is 12, squared times theta, which is 2.3. And if you put this into your calculator, it's equal to 165.6. So this here is the area of the sector. Okay, so now what we want to do is to figure out the area of these two triangles here. Now, as we're told these triangles are congruent, they're identical, therefore we don't need to figure out the area of both of the triangles. We only need to figure out the area of one of them and then just multiply this by 2 because the areas of the triangles are going to be the same, okay? So if we focus on this triangle that I've highlighted here in orange, this AOB, for the sake of kind of drawing it a bit bigger, I've drawn it down here, so this is going to be AO be like this here, okay? So what do we know about this triangle? Well, we figured out in part B that the size of the angle AOB, so this is this angle here, is 0.421 radians, okay? So this angle here is 0.421. Now, the easiest way to figure out the area of a triangle like this is using that the area of a triangle is equal to half AB sin C. Now, this C here, we can use this angle here, this 0.421. So we'll call this C. So that means we need the area of this side here and this side here. So we'll call this side A and we'll call this side B. Okay, let's start with this side here A because this is easier. So this is this side here, so we can see that this is AO. Now we are told that AOG, this line here, is 15 meters, and we can see that the line AOG is made up of AO and OG. These two, AO, is going to be equal to OG. They're going to have the same length because again the triangles are congruent, so these sides are going to be the same length. So therefore if AOG, the whole thing together, is made up of 15 meters, that means that AO and OG are going to be the same. They're both going to be 7.5 meters because 7.5 times 2 is 15. So therefore AO is equal to 7.5 meters, as OG is going to be as well. So this is 7.5 and this is 7.5. So we can add this to our diagram that A is equal to 7.5. Now B is a bit more difficult, okay? So B, if we look at it, is this line here, okay? Now this line is actually made up of two different lines. It's made up of OC and it's made up of CB. Now we know OC, this is the radius, this is equal to 12. However, we don't know what BC is. Now, what we can do though is we can figure this out using this information that the total length of the front of the stage, BCDEF, is 35 meters, okay? So if we look at what this is saying, so BCDEF, so it's going to be BCDEF. This is this side here, and this entire thing is equal to 35 meters. If we look at what BCDEF is made up of, it's made up of this side here, which is BC, plus this arc here, which is CDE, plus this side here, which is EF. Okay, so let's plug in some numbers here. We know that BCDEF, this entire thing, is 35 meters. BC, let's call this X. Okay, so let's say this is equal to X. CDE is this arc here, and we know that this arc, we're told, is 27.6. And EF, which is this side here, this is also going to be X, because again, these triangles are congruent, they're identical, so BC and EF are both going to be equal to X. So it's going to be 35 is equal to, and then X plus X is 2X plus 27.6, so then it's going to be 35 minus 27.6, which is going to be equal to 7.4. This is equal to 2x, and then x is going to be equal to 7.4 divided by 2, which is going to be equal to 3.7. So x is equal to 3.7, and what we can do with that is then this OC is equal to 12, and x here is equal to 3.7, so therefore the entire line OB is equal to 12 plus 3.7, which is equal to 15.7. So therefore this side here, B, is equal to 15.7. So now we can figure out the area because we know A, B, and we know C. So the area is equal to half times A, which is this 7.5 here at the bottom, times B, which is this 15.7, times sin C, which is this angle here, this 0.421. If you put this into your calculator, you get out a value of 24.061 if you round it to 3 decimal places. Okay, so therefore the total area of this entire shape is going to be this sector here, which we figured out is this 165.6, plus, and then it's the area of these two triangles here. Now we know the area of one triangle is 24.061, so it's going to be 2 times 24.061 because there's two triangles. If you put this into your calculator, it's equal to 213.722. If you look at the question, it wants it to the nearest square meter. Remember, this is in meters squared, so if it wants it to the nearest square meter, this is going to be 214 meters squared. Just really quick, in terms of the marks, you get 1 mark for using this formula here to find the area of the sector, and you get another mark for getting this 165.6. You get a mark for finding this OB, this 15.7, this side here. You get another mark for finding the area of the triangle. You get another mark for using this formula here to find the total area of the triangle, and you get 1 mark here for getting this final answer of 214. Okay, so for question 9, we're told that the first 3 terms of a geometric sequence are 3k plus 4, 12 minus 3k, and k plus 16, where k is a constant. And for part A, we need to show k satisfies this equation here for 2 marks. So as the question tells us, this is to do with geometric sequences and series. So if you remember how a geometric sequence works, so we have a common ratio which we call r, and that's how we get from each term. So starting with the 3k plus 4 to get to this term here, we multiply by a common ratio which we call r, and then to get from this term to this term we also multiply it by r, and so forth. So how do we get to this equation here? Well, the easiest way to do this is if we look at getting from the first term, 3k plus 4, to the second term, 12 minus 3k, we multiply it by r here. So it's going to be this 3k plus 4 multiplied by r is equal to 12 minus 3k. If you divide both sides by this 3k plus 4 here to bring it onto this side, you get that r is equal to 12 minus 3k over 3k plus 4. If we do this exact same thing for the second term and the third term, so to get from the second term to the third term, it's going to be this 12 minus 3k multiplied by r is equal to k plus 16, and then divide both sides by this 12 minus 3k, so we get that r is equal to k plus 16 over 12 minus 3k. As both of these equations here are equal to r, we can equal them to each other. So we can say that 12 minus 3k over 3k plus 4 is equal to k plus 16 over 12 minus 3k. So we've equaled these two to each other, and now what we can just do is rearrange this in order to get it into this format here. So what we're first going to do is to multiply both sides by 12 minus 3k to move this denominator onto this side. So it become 12 minus 3k multiplied by 12 minus 3k over the 3k plus 4 is equal to this k plus 16, and then we're going to do the exact same thing with this denominator here, this 3k plus 4, to bring onto this side. So it becomes 12 minus 3k, 12 minus 3k is equal to k plus 16 multiplied by 3k plus 4, and now we're going to expand these brackets here. Okay, so 12 times 12 is 144, and then minus 3k multiplied by 12 is minus 36k, and we have this again here, so it's going to be another minus 36k, and then 12 times, minus 3k times minus 3k is going to be plus 9k squared, and then this is going to be equal to k times 3k, which is going to be 3k squared, and then 16 times 3k, which is going to be 48k, and then 4 times k, which is going to be 4k, and then 16 times 4, which is going to be 64. We can do some simplifying here. So here, let's write this in kind of the more quadratic form when we write this 9k squared first, minus 36k minus 36k is going to be minus 72k, and then plus the 144, and this is equal to 3k squared plus 48k plus 4k is equal to 52k, and then plus 64, and then let's bring all of this stuff here, this 3k squared plus 52k plus 64, let's bring it onto this side here. So it's going to be 9k squared minus 3k squared, so this is going to be 6k squared, and then minus 72k minus this 52k is going to be equal to minus 124k, and then this 144 minus this 64 here is going to be equal to plus 80, and this is equal to 0. So we need to get it into this format here. Now here, if we have 6 minus 124 and 80, these are all divisible by 2, so we divide everything by 2 here, it will become 3k squared minus 62k plus 40 is equal to 0. So we have this equation here, and this is what's required. This 3k squared minus 62k plus 40 is equal to 0. To get the 2 marks here, you get 1 mark for getting this equation here, and you get another mark for rearranging it into this format here. Okay, so for the first part of B, we're told that the sequence converges, and then using this, we need to find the value of k, giving a reason for our answer, okay? So as the sequence converges, this means that r, which is this common ratio here, the modulus of r is going to be less than 1. Another way you can write this is that r is going to be between minus 1 and 1. Okay, so what can we do with this information? Okay, so firstly, let's go back to what we found in part A. We found this quadratic here for k, this 3k squared minus 62k plus 40 is equal to 0. Okay, let's solve this quadratic in order to get out the 2 possible values for k. Now, there's loads of ways that we can solve quadratics. I'm just going to use the quadratic formula. So remember, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a, where a is 3, b is minus 62, and c is 40. So therefore, if we write this out, it's going to be minus b, so it's going to be minus 62 plus or minus the square root of b squared, so minus 62 squared, minus 4a, so a is 3, c, which is 40, and all of this is over 2a, so 2 times 3, and this here is going to be what k is equal to. If you put this into your calculator, you get out 2 values. You get that k is either equal to 20 or k is equal to 2 over 3. Okay, so which one is it? Is k equal to either 20 or 2 over 3. So as the sequence converges, we know that r has to be between -1 and 1. And in part A, we got an equation for r. We got two equations for r. Let's use this one here, okay? So let's use the fact that r is equal to 12 minus 3k over 3k plus 4. Let's sub these two k values in, k is equal to 20 and k is equal to 2 over 3 into this and see what r values we get out, okay? So if we say if k is equal to 20, that means that r is going to be equal to 12 minus 3, and then instead of k, it's going to be 20 over 3, and then instead of k, it's going to be 20 plus 4, like this here. And if you put this into your calculator, you get out a value of minus 3 over 4. Okay, so if k is equal to 20, r is equal to minus 3 over 4. If k is equal to 2 over 3, therefore r is going to be equal to 12 minus 3, sorry, 3 and then 2 over 3, and this is over 3 times 2 over 3 plus 4. And if you put this into your calculator, it gives out a value of 5 over 3. Now, this is useful to us because we know that r has to be between -1 and 1. Well, if k is equal to 20, r is equal to minus 3 over 4. So this one's fine, we can work with this one. However, if k is equal to 2 over 3, r is equal to 5 over 3. So therefore, this is not a solution because r cannot be equal to 5 over 3 because it's not between -1 and 1. So therefore, k is not equal to 2 over 3. K is equal to 20, where r is equal to minus 3 over 4, and that there is the final answer. In terms of getting the 2 marks, you get 1 mark for attempting to solve this quadratic here in some way, and then you get another mark for showing that k is equal to 20 and giving a reason for your answer. If you just show kind of this information up here, that r has to be between -1 and 1, this is enough of kind of a reason to get the mark. Okay, and then for the second part of B, we need to find the value of the sum to infinity. So the sum to infinity is given by this formula here. This is actually given to you in the formula booklet, where A is the first term in the sequence and R is the common ratio between the terms. Okay, so here A is the first term in the sequence, and we know that the first term is this 3k plus 4, and now we know what k is. We know that k is equal to 20, so we can sub this in. So it's going to be 3 and then 20 plus 4, and this is equal to 64. So therefore A, the first term, is equal to 64, and then R, which is the common ratio, we figured out in the previous question that if k is equal to 20, then R is equal to minus 3 over 4. So R is equal to minus 3 over 4. So therefore, we're going to sub these values into the sum of infinity, okay? So it's S infinity is equal to 1 minus 3 over 4, and this is under A, which is 64. And if you put this into your calculator, you get out a value of 256 over 7, and this here is the answer. This is the sum to infinity. You get the 3 marks here. You get 1 for showing that A is equal to 64 and R is equal to minus 3 over 4. You get another mark for plugging them into this formula here, and you get another mark for getting the final answer. Okay, so for question 10, we're told about a circle C that has this equation here, where k is a constant, so k is here and here. And for part A, we need to find, in terms of k, the coordinates of the center of the circle and the radius of the circle, and this is for 3 marks. Okay, so this is to do with year 1 chapter 6 content, to do with the equation of a circle. Okay, so if you remember, to get the center of a circle and the radius of the circle, we need the equation of the circle in the form x minus a squared plus y minus b squared is equal to r squared, where the center is equal to AB, and the radius is equal to r. Now we don't have this equation in this format here. In order to convert it into this format, we need to complete the square on the x and the y terms. Okay, so let's rewrite this in order to get the x and the y terms together. So it's x squared, and then we have this 6k x, and then it's plus y squared, and then we've got this minus 2ky, and then we've got this plus 7 on the end, and this is equal to 0. So we've grouped the x terms and the y terms together, so we need to complete the square on both of them. Okay, so let's start with the x squared plus 6kx. Now to complete the square on this, remember, so it's going to be x plus, and then what we're going to do, the coefficient of this x here, which is 6k, we're going to half this, so it's going to be 3k, and then this whole thing is going to be squared, and then we're going to minus this number here squared. So 3k squared is 9k squared, so we're going to minus 9k squared like this here. And then if we focus on this y squared minus 2ky, so it's going to be y, and then we're going to half this minus 2k here, so this is going to be minus k, and then it's going to be the power of 2 like this, and then we're going to minus this number here squared, so minus k squared is going to be k squared, so we're going to minus k squared like this here. So if we rewrite this, it's going to be, with the completed square format, it's going to be x plus 3k squared minus 9k squared, and then it's going to be plus y minus k squared like this here, and then we've still got this plus 7 here, and this is equal to 0. We can do some simplifying here, so we have x plus 3k squared, and then let's write this y term here, so plus y minus k squared like this here, minus 9k squared minus k squared is going to be minus 10k squared, and then plus 7 is equal to 0. Let's bring this minus 10k squared plus 7 onto the other side, so it's going to be k plus 3k squared plus y minus k squared is equal, so if we bring this to the other side, it's now going to be 10k squared minus 7 like this here. So now we have this in this format here, where the center is going to be, so this here, remember, it's this minus a here, so it's a, so here it's going to be minus 3k, and then the y term here is going to be plus k like this here, and the radius is going to be the square root of this number here, so it's going to be the square root of 10k squared minus 7. So this is the center and this is the radius. So this is worth 3 marks. You get the 3 marks. You get the first one for getting it into kind of this completed square format here. You get the second one for getting the center, and you get the third one for getting the radius. Okay, so for part B, we're told that the line with equation y is equal to 2x minus 1 intersects C at 2 distinct points, and we need to find the range of possible values of k for 6 marks. Now, this question, we talked about questions like this in the circles and straight lines video. The way that we do this is this y is equal to 2x minus 1. We're going to sub this in to the equation of the circle. We're going to sub out the y terms for 2x minus 1. Now you might be tempted to, and this is the way that I initially did it, is to do it for this equation here that we figured out in part A. So we would sub out y here for the 2x minus 1. You can do it this way, however you actually find that if you instead use this equation, it's a lot simpler, there's a lot less work to do. You can still do it this way down here, but it involves a lot more working out. So what we're going to do with this equation up here, for the y terms here, we're going to sub in this 2x minus 1. So if we do this, it's going to be x squared plus, and then instead of y squared, it's going to be 2x minus 1 squared. Then it's going to be plus 6k x, and then minus 2k, and then instead of y, it's going to be 2x minus 1, and then plus 7 is equal to 0. And what we're going to do, we're going to simplify this, okay? So firstly, we have this x squared plus, and then we're going to expand this 2x minus 1 to the power of 2. So we're going to have 2x times 2x, which is going to be equal to 4x squared. We're going to have minus 1 times 2x, which is going to be minus 2x, but remember that we're going to have this twice, so it's going to be minus 4x, and then minus 1 times minus 1 is going to be plus 1, and then we've got this this plus 6k x, and then minus, and then we've got this minus 2k times this 2x, which is going to be 4k x, and then we have this minus 2k times minus 1, which is going to be equal to plus 2k. Then we have this plus 7 on the end, and this is equal to 0. We can simplify this by collecting the terms, so we have x squared plus 4x squared, which is going to be equal to 5x squared. We have this 6kx minus 4kx, which is going to be equal to 2kx, and then we have this minus 4x. Here we have this 2k here, so it's going to be plus 2k, and then we have this plus 1 plus 7, which is going to be plus 8, and this is equal to 0. Now this here is a quadratic for x. It might be easier to see this if we write it as 5x squared, and then here we factorize out the x, so it's going to be plus bracket 2k minus 4, and then x like this here, and then here it's going to be plus this 2k plus 8, and this here is equal to 0. Okay, so what do we do with this here? Well, we're told that the line of equation y is equal to 2x minus 1 intersects C at two distinct points. If it intersects C at two distinct points, that means that this equation down here, the discriminant, so b squared minus 4ac, is going to be bigger than 0. Remember, it's bigger than 0 if there are two distinct points, it's equal to 0 if there's 1 point of intersection, and it's less than 0 if there are no points of intersection. But here it's bigger than 0 because there are two distinct points of intersection. So therefore what we're going to do, with 5 being A, 2k minus 4 being B, and 2k plus 8 being C, we're going to use the discriminant here. So again, it's b squared minus 4ac is bigger than 0. So therefore this here is going to be 2k minus 4 squared minus 4a, which is 5, and then c, which is 2k plus 8, and this here is bigger than 0. Okay, so we can simplify this. So here we have 2k plus 4 to the power of 2, so it's going to be 2k times 2k, which is going to be equal to 4k squared. We've got minus 4 times 2k, which is going to be equal to minus 8k. Remember, there's going to be two of them, so it's going to be minus 16k, and then we're going to have minus 4 times minus 4, which is going to be plus 16, and then we have this minus 4 times 5, which is going to be minus 20, and this is going to times the 2k plus 8, and this is going to be bigger than 0, and then we're going to expand this further, so it's going to be 4k squared minus 16k plus 16, and then it's going to be minus 20 times 2k, which is going to be minus 40k, and then minus 20 times 8 is going to be minus 160, and this is bigger than 0. Collect the like terms, so this is going to be 4k k squared. We've got minus 16k minus 40k, so this is going to be minus 56k, and then plus 16 minus 160 is going to be minus 144, and this is bigger than 0. Now here, all of these coefficients are divisible by 4, so we divide everything by 4 to simplify it. It's going to be k squared minus 14k minus 36 is bigger than 0. Okay, so using this is a quadratic inequality. The way that we solve this is, so firstly, let's rewrite it as if it's equal to 0. So k squared minus 14k minus 36 is equal to 0. And let's solve this. There's no easy way to factorize this, so we're going to use the quadratic formula. Remember, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a, where here a is 1, b is minus 14, and c is minus 36. So if we use this, it's going to be minus b, so it's going to be minus 14 plus or minus the square root of b squared, which is going to be minus 14 squared, minus 4a, which is 1c, which is minus 36, and all of this is over 2a, so it's going to be 2 times 1, so this is what k is going to be equal to for this equation here. And if you put this into your calculator, you get that k is equal to 7 plus or minus root 85. Okay, so what this means is that k is equal to either 7 plus root 85 or 7 minus root 85. Now, the way that we solve this from here is, let's draw this quadratic here with these roots. So if we draw this, so if we draw a graph, so we say that this is y and this is x, or I guess k in this instance. We draw this quadratic here, so it's a positive parabola because the coefficient of k squared is positive. So it's going to look something like this here, where this root here is the 7 plus root 85, and this here is the other root, which is the 7 minus root 85. Okay, so what do we do with this? Okay, so we need to find where this quadratic here is bigger than 0. So this is where it's going to be above the k axis here. When it's positive, it's bigger than 0. So we can see that this is here and here. Okay, so we focus on this part here. This is where it is less than 7 minus root 85, because it's going in this direction here. So here, this is where k is less than 7 minus root 85, and then over here, this is where k is bigger than 7 plus root 85. So here k is bigger than 7 plus root 85. So therefore, in order for there to be two distinct points of intersection, in order for this quadratic to be bigger than 0, therefore either k has to be less than 7 minus root 85, or k has to be bigger than 7 plus root 85. And this here is the final answer. And then really quick, to get the 6 marks here, you get 1 mark for getting some kind of quadratic here. It doesn't matter what the coefficients are, as long as you get some quadratic. And then you get the 2nd mark for getting the coefficients correct. You get the 3rd mark for using the discriminant here and trying to rearrange in order to get an inequality for k. You get another mark for showing this 7 plus or minus root 85 here. You get another mark for getting one of these inequalities here, and then you get the other mark for getting the other one. Okay, so for question 11, we're given this model here. V is equal to AB to the power of t, where V is the value of a mobile phone in pounds and t is the amount of months after it was bought. And we have this model here where A and B are constants. And we're also given figure 2 that is up here. And this is a linear relationship between log base 10 of V and t. And we're given a couple of points on figure 2. We're given 0, 3 here, and 10, 2.79. And using these points for part A, we need to find the initial value of the phone for 2 marks. Now, this question is to do, we talked about questions like this in the non-linear data and exponential modelling video that we made back in year 1 of chapter 14. If you struggled with this question, I'd really recommend going back to that video. I think there are a lot of students that struggle with questions like these, so I'd really recommend going back to the video. Part A isn't too bad. So we need to find the initial value of the phone. Okay, so firstly, let's look at this graph up here. So we're told that this is a linear relationship, so this is a straight line. In this example, this y-axis here is y is equal to log base 10 of v. Remember, when you have base 10, you don't need to write base 10, we can just write this as log v. So in this question, the y-axis is log v, and the x-axis is t. Okay, so we need to find the initial value of the phone. The initial value of the phone is going to be where t is equal to 0. Whenever you see initial in terms of kind of like time, like t months, it's going to be where t is equal to 0. And we're given this point on the graph where t is equal to 0. It's this 0, 3 here. So here, y is equal to 3. We know y is equal to log v, so therefore log v is equal to 3. Now we're looking for the value of the phone that is represented by v, so all we just need to do here is make v the subject. So as we've got log base 10 of v here, v is going to be equal to 10 to the power of 3, which is equal to 1,000. So the initial value of the phone when it was bought after 0 months, so its initial value when it was bought, is 1,000 pounds. You get the 2 marks here. You get one of them for showing it's equal to 10 to the power of 3, and you get the other one for showing it's equal to 1,000. Okay, and then for part B, we need to find a complete equation for V in terms of t, given the exact value of A and giving the value of B to 3 significant figures, and this is worth 3 marks. Okay, so essentially what this question is asking is, this is the equation for V in terms of t. V is equal to AB to the power of t. We just need to find what the constants A and B are. Okay, so this is where I think a lot of students struggle with questions like these, and again, I'd recommend going back to that video. So the way that we're going to find the values of the constants A and B is by using the information that we're given about these 2 points here. We're given 2 points on this graph, 0, 3 and 10, 2.79. The issue here though is this graph has the y-axis as log v and the x-axis is t, whereas here we don't have a log v, we have v is equal to ab to the power of t. So what we're going to do, okay, what we're going to do is we're going to focus on this v is equal to ab to the power of t, and what we're going to do is we're going to take logs of both sides, log to base 10. So we're going to say that log of v is equal to log of a b to the power of t. Okay, so we can do some simplifying here. So if you remember the laws of logs, if you have 2 logs that are added together, so for example log a plus log b, you can combine them into one log by multiplying what's together in the log. So it's going to be log a b like this here. We have this here in the opposite way. We have this log of a multiplied by bt, so we can split this up into 2 different logs by adding them together. So we can write this here as log v is equal to, and then rather of log of a multiplied by bt, we can write this as log a plus log of bt t, like this here, okay? We can do some more simplifying here because we have log v is equal to log a plus, and here we have this power of t inside the log. Remember, when you have a power of t like this, when you have a power inside a log, you can bring this to the front as a coefficient. So we can write this as t log b, okay? So what's useful about this? So it might be easier to see this if we write this as log v is equal to log of b multiplied by t plus log a. And this here is a straight line. The reason that this is a straight line is if you look up this up here, we have y is equal to log v and x is equal to t. Now here we have log of v, so this here is y and this t here is x, okay? So this here is y and this here is x. This log b, remember b is a constant, so therefore log b is also going to be a constant. This here is the gradient m, and then plus log a, again a is a constant, so log a is also going to be a constant. This here is going to be the y-intercept, so this is in the form y is equal to mx plus c, where y is log v, x is t, and this is what it's like on this graph here, where y is log v and x is t. M is equal to log b, and c is equal to log a. And what's useful about this is we can find m, which is the gradient, and c, which is the y-intercept of this graph here. And then what we can do, if we find the gradient and the y-intercept, we can therefore plug it into here and then find what b and a are and sub them into this here in order to get the full equation, okay? So let's start with this here, that c is equal to log a, because this is easier. So c is the y-intercept, and we can see that the y-intercept is here, and this is this 0, 3 here. This is the y-intercept. So therefore here the y-intercept is equal to 3, so therefore c is equal to 3, so therefore log of a is equal to 3. To make a the subject, again, it will be a is equal to 10 to the power of 3, which is equal to 1,000. So a is equal to 1,000. So we found the value of the constant a. Now we need to find the value of the constant b. So this is the gradient. Now we can find the gradient because we have 2 points on this line. Remember, the gradient is equal to y2 minus y1 over x2 minus x1, and we have 2 coordinates here, okay? So therefore this is going to be, the gradient is going to be y2, let's call this the second point, let's call this the first point. So y2 is going to be 2.79 minus y1, which is going to be 3. And this is over x2, so this is the x coordinate of the second point, which is 10 minus x1, which is 0. Okay, if you put this into a calculator, you get out that m is equal to minus 0.021. As m is equal to log b, this means that log b is equal to minus 0.021. So to make b the subject and find b, it's going to be b is equal to 10 to the power of minus 0.021. If you put this into a calculator, it gives out the value. It says in the question it wants b to 3 significant figures. This is going to be equal to 0.953 if you put it into your calculator. So we have found the value of a and b, so therefore we can plug this into this equation here. The equation is v is equal to ab to the power of t. So if we plug these values in, we're going to get that v is equal to a, which is 1,000, multiplied by b, which is this 0.953 to the power of t. And this here is the answer to the question, where we found a complete equation for v in terms of t, and we found what a and b are. Really quick, in terms of the marks here, you get 1 mark for figuring out that the gradient is equal to minus 0.021. You get another mark for figuring out that b is going to be equal to 10 to the power of minus 0.021. And then you get another mark for the final answer. Okay, and then for part C, we're told exactly 2 years after it was bought, the value of the phone was £320, and we need to use this information to evaluate the reliability of the model for 2 marks. Okay, so remember T is in months, so if it's exactly 2 years after it was bought, t would be equal to 24, because it would be 24 months. Okay, so what we're going to do, this t is equal to 24, we're going to sub this into our model here and get out the value of v, which is the value of the phone that our model predicts, and we're going to compare this to the actual value, which is this £320, and see how accurate it is. Okay, so if we sub in t is equal to 24, it's going to be v is equal to 1000 times 0.953 to the power of 24. If you put this into your calculator, it gives out a value of 314.94. We round it to the nearest pound. It's equal to £315. If we compare this to the actual value, it's £320. £315 is very close to £320. It's of course not going to be exactly accurate because it's just a model, but this is a pretty accurate estimate for the value of the phone after 2 years. So therefore, what we can say it says in the question, it says use this information to evaluate the reliability of the model. So let's say some sort of statement. So we'll say something like 315 is approximately equal to £320. So therefore, the model is reliable. Something like that will give you the 2 marks. You get the 2 marks. You get the first mark for finding this here, that the estimated value is about £315, and you get the second mark for showing that the model is reliable. Again, I know it's not exactly £320, but this is close enough. Again, the model will never be 100% accurate. This is close enough to say that the model is reliable. Okay, so for question 12, we're told that y is equal to sin x, and we need to use differentiation from first principles to show that dy over dx is equal to cos x, and this is for 5 marks. So this is obviously a differentiation from first principles question. I've given you the formula for first principles, and I've given you the addition formula for sin of a plus b, because they're both given to you in the formula booklet. Okay, so to do this, what we're going to do is we're firstly going to say that f of x is equal to sin x, okay, because this is what we're trying to differentiate. So therefore, to differentiate this, it's going to be f dash of x is equal, so if we use this formula here, so it's going to be the limit as h approaches 0 of f of x plus h, so this is going to be sin of x plus h, and then minus f of x, so this is just minus sin x, and all of this is over h, like this here. Okay, so from here what we can do, so f dash of x is equal to the limit as h approaches 0. So we can use the addition formula here for sin of x plus h, so it's this formula up here. So it's going to be sin, so a here is x and b is h. You can use them interchangeably, but we'll call it that. So sin a is going to be sin x, and then cos b is cos h, and then it's going to be plus cos a, so that's cos x, and then sin b, so that's going to be sin h, and then we've still got this minus sin x at the end, and all of this is over h. Okay, so f dash of x is equal to the limit as h approaches 0. So what we're going to quickly do, we have sin x and sin x here. I'm quickly going to group these together. So I'm going to write this first. So this cos x sin h, and then I'm going to group these sin x terms together. So sin x cos h minus sin x, like this here, and this is all over h. So what we can do now, so f dash of x is equal to the limit as h approaches 0 of, so we're going to split up, because we've only got one term in the denominator and we've got three terms in the numerator. We can split this up. We can write this as cos x sin h over h plus sin x cos h minus sin x over h, like this here. Now if we look at this here, so we can assume that as h is approaching 0, sin h over h is equal to going to approach 1, and cos h minus 1 over h is also going to approach 0 here. Okay, so what we can do here is you can see that we've got this cos x sin h over h, we've got this sin h over h. So if we factorise cos x out of this, it's going to be f dash of x is equal to the limit as h approaches 0. So if we factor out cos x from this, we'll be left with sin h over h. So we know that this here approaches 1, and then it's going to be plus. Now here we have sin x cos h minus sin x over h. Here we have cos h minus 1 over h approaches 0. So we have this cos h minus 1 over h if we factorise out sin x. So it'll be sin x, and then it will be cos h minus 1 over h, like this here. So what we can do with this, so f dash of x is equal to, so as we're approaching, as h is approaching 0, as sin h over h is going to approach 1, and as cos h minus 1 over h is going to approach 0, what we can do is we can sub these out now and get rid of this limit here. So we can write this as f dash of x is equal to cos x, and then instead of sin h over h here, this can be written as 1. We can sub this out, plus sin x multiplied by, in this cos h minus 1 over h, we can write this as 0, and then therefore f dash of x is equal to, so cos x times 1 is just cos x, and then sin x times 0, this will just cancel out, so therefore we're just left with cos x. Therefore f dash of x is equal to cos x. As f of x is equal to sin x and f dash of x is equal to cos x, this means that dy over dx is equal to cos x. So we've proved that dy over dx is equal to cos x. In terms of the marks here, you get 1 mark for subbing in sin x for the first principles formula. You get 2 marks for using the addition formula here and getting this line. You get another mark for writing it like this, where you sub out these terms here for 1 and 0, and you get a final mark for saying that dy over dx is equal to cos x. Okay, so for question 13, we're told about a model for a roller coaster, and on the ride, carriages complete multiple circuits of the track, such as the maximum vertical height of a carriage above the ground is 60 meters. A carriage starts a circuit at a vertical height of 2 meters above the ground, and the ground is horizontal, okay? And we're given this model here, where h is equal to a minus b t minus 20 to the power of 2. Where h is the vertical height of the carriage above the ground in meters, and t is the amount of seconds after the carriage starts the first circuit. And we have this here, where h is equal to a minus b t minus 20 to the power of 2, where a and b are positive constants. So for part A, we need to find a complete equation for the model for 3 marks. So essentially what you need to do, this is the equation here. To get a complete equation, we just need to find what the constants a and B are, okay? So this is a quadratic question because this model here is a quadratic. It's currently in the completed square format, which is really useful to us as I'll come on to in a moment, okay? So let's start with this first bullet point here, that the maximum vertical height of a carriage above the ground is 60 meters. Now, if we look at this model here, as I said, this is a quadratic. This is in the completed square format at the moment. If we expanded this out into kind of the quadratic equation, because we have this minus b multiplied by this bracket here, if you fully expanded it, it would be a negative parabola because the coefficient of t squared would be negative. It would be something like minus t squared. So it'd be a negative parabola, so it will look something like this here. And we're told the maximum vertical height of a carriage above the ground is 60 meters. So therefore here, h is equal to 60. And we can see that this maximum height is going to be here. And this here is the turning point. This is going to be the maximum height because if we think about drawing this like with a y and an x-axis, or in this case an h and a t-axis, this here is going to be the highest point that h can be. So this is going to be the maximum. This is where h is equal to 60. Now, one thing that's really useful to us here is this is in the completed square format, this model. So if you don't remember the completed square format, if we're doing it in terms of y and x, it's y is equal to, and it's going to be something like c and then x plus p and then squared and then plus q, like this here. This is the completed square format. And one thing that's really useful about the completed square format is it's really easy to find the turning point. You might have to go back to year 1 of chapter 2 to remember this, but the turning point when it's in the completed square format is equal to minus p q, where p is this number here inside the bracket to the power of 2 with the x, and q is this number here. So if we look at our completed square format here, we can see that this p here is this minus 20, and the q here is this a. So the turning point is going to be minus p, so it's going to be minus 20, so it's going to be 20, and then it's going to be a here. However, we know that the turning point, the h coordinate here, is going to be 60. This is the maximum vertical height of the carriage. So therefore this here we know is 60, so therefore a is equal to 60. Okay, so we found what a is. Okay, so if we sub this in, we've got that h is equal to, instead of a here, we can write 60, and then it's minus b, and then t minus 20 squared. Okay, so we found what a is, so now we need to find what b is. And the way that we can do this is by using this second bullet point here, that a carriage starts a circuit at a vertical height of 2 meters above the ground. So if it's a vertical height of 2 meters, therefore h is equal to 2, and then it's when the carriage starts the circuit, so therefore here t is equal to 0. This is kind of the initial time for when the carriage starts. So therefore what we're going to do is sub into this equation here, h is equal to 2 and t is equal to 0. So if we do this, so h is equal to 2, so it's going to be 2 is equal to 60 minus b, and then instead of t here we've got 0 and then minus 20 squared, like this here. Okay, so this is going to be 2 is equal to 60 minus b. 0 minus 20 is just minus 20, like this here, and it's squared, so it's 2 is equal to 60, and then we've got this minus 20 squared, which is going to be 400, so it's going to be minus 400 b, like this here. If we bring the 60 onto the other side, so it's 2 minus 60, which is going to be minus 58, and this is equal to minus 400b, and then divide both sides by 400, so we get the B is equal to 58 over 400, which is equal to 29 over 200. So this is the value of B, 29 over 200. So therefore we can write out a complete equation for this model by subbing in A and B. So it's going to be H is equal to, so A is 60, and then minus B, which we now know is 29 over 200, and then it's going to be the T minus 20 squared. In order to get the 3 marks here, you get 1 mark for figuring out that A is equal to 60. You get another mark for realizing kind of here that H is equal to 2 and T is equal to 0, and then subbing this in and trying to figure out B, and then you get the final mark for finding the full equation. Okay, and then for part B, we need to use the model to determine the height of the carriage above the ground when t is equal to 40. So all we're just going to do here is sub in t is equal to 40 into our equation that we found here. So this is going to be h is equal to 60 minus 29 over 200, and then for t here we're subbing in 40, so it's going to be 40 minus 20 squared like this is. So therefore h, if you put this into your calculator, is equal to 2. So h is going to be 2 meters. Okay, and then for part C, we're given this different model here that is a trigonometric function, and this is h is equal to 29 cos of 9t plus alpha, and this is in degrees, plus beta, where alpha is between 0 and 360 degrees, where alpha and beta are constant. So for part C, we need to find a complete equation for this alternative model for 2 marks. So we essentially just need to find what alpha and beta are. Okay, so this is a trigonometric modeling question. Okay, so if we look at this first bullet point, so the maximum vertical height of a carriage above the ground is 60 meters. So as we talked about already, this here is h is equal to 60, and this is the maximum height. Okay, so this is going to be where this equation is maximum. Okay, so h is equal to 60 at the maximum of this equation here. So the question is, when is this equation at its maximum, and then this will be equal to 60? Okay, well, as we talked about before with trig functions, this cos here, it doesn't matter what is inside the trigonometric function here, it doesn't matter. The maximum value that cos can have, the maximum value that cos can have is 1. Again, it doesn't matter what is inside the trigonometric function here. The biggest value that cos can have, if you look at a cos graph, is 1. So if we're trying to maximize this equation here, this is going to be where cos is at its maximum of 1. So what we're going to do is we're going to sub this in for cos. We're going to sub in 1. So it's going to be 29, and then instead of this cos function here, it's going to be the maximum, which is 1, and this is plus beta, and the maximum is where h is equal to 60. So h is equal to 60 here, and therefore we can rearrange this in order to find beta. So this is going to be 60 is equal to 29 plus beta. Move the 29 to the other side, so we get that 31 is equal to beta. Okay, so this is the value of beta, so if we sub this in, it's going to be h is equal to 29 cos 9t plus alpha plus, and then instead of beta it's 31 like this here. Okay, so now we need to find alpha, and this is where we're going to use the second bullet point, where a carriage starts a circuit at a vertical height of 2 meters above the ground. So as we talked about already, this is where h is equal to 2 and t is equal to 0. So we're going to sub this in to this equation here and then rearrange in order to find alpha. So h is equal to 2, so it's 2 is equal to 29 cos of 9, but instead of t it's going to be 0 here, plus alpha plus 31 like this here, and then we're going to rearrange in order to find alpha. This is 2 is equal to 29 cos, and then 9 times 0 is 0, so in the cos function here it's just going to be alpha like this here, plus 31. Move this 31 to the other side, so it's 2 minus 31, which is equal to minus 29, is equal to 29 cos alpha, and divide both sides by 29, so we get minus 1 is equal to cos alpha. Okay, if we look at a cos graph, so if we draw a y and an x-axis here, it's going to look something like this. So this is the graph y is equal to cos x, whereas this is 0. So we're told that alpha is in the interval of 0 and 360 degrees. So let's consider it in this integral. So this here is 0, this here is 90, this here is 180, this here is 270, and this here is 360. If minus 1 is here, there is one value in this interval for when cos x is equal to minus 1, and this is at 180. So cos of 180 is equal to minus 1, so therefore here alpha is equal to 180 degrees. So therefore, if we sub this into this equation, it's going to be h is equal to 29 cos of 9t plus alpha, which is 180, plus beta, which we've already figured out, is 31. And this here is a complete model where we found alpha and beta. You get the 2 marks here. You get the first mark for finding either alpha or beta, and then you get the second mark for finding alpha and beta. Okay, and then for part D, we're told that given that the carriage moves continuously for 2 minutes, we need to give a reason why the alternative model would be more appropriate for 1 mark. So this is this second model here, okay? So let's compare the 2 models. So this one here is a quadratic, which, as we already talked about, is a negative parabola. So it's going to look like this here, where this model here is trigonometric, so as it has this cos here, it's going to oscillate, so it's going to look something like this here. The reason that this one is a better model is we're told that carriages complete multiple circuits of the track. Okay, so if we consider what's going on here, so remember h represents the vertical height of a carriage above the ground. Okay, so the ride is going to start here, for example. In fact, we're told it starts at a vertical height of 2 meters and then it reaches a maximum of 60 meters. So it's going to go up to 60 and then it's going to go back down like this here. Now this scenario both of the models can work with, so this is fine. The problem is when t starts to get bigger, so when the ride keeps going, it completes multiple circuits. So ideally we want this model to kind of look like this here, where it keeps going up and down to represent multiple circuits, kind of the roller coaster going up and down. The issue with this first model is, as this is a parabola, this isn't going to do this. This is just going to keep going down this parabola. So if we consider, given that the carriage moves continuously for 2 minutes, as t is in seconds, this is going to be where t is equal to 120. Okay, if we sub this in to our first model, so this is this here that we found for part A, so t is equal to 120. This is going to be h is equal to 60 minus 29 over 200, and sub in t is 120 minus 20 squared. If you put this into your calculator, you get out a value of minus 1390 meters, and hopefully you can obviously see the flaw with this is this parabola essentially just keeps saying that the ride will keep going down forever, and it gives this value here that doesn't make any sense. It's kind of going into the ground. However, if you consider this second alternative model here that we figured out in part C, so it's going to be h is equal to 29 cos of 9, and instead of t it's 120 plus 180 plus 31. If you put this into your calculator, this is equal to 2 meters. This is why this model works better, because it kind of has this oscillating model where it keeps going up and down like this, rather than the first model where it kind of keeps going down. So essentially, give a reason why the alternative model would be more appropriate. You can say something like the alternative model allows for multiple circuits. Okay, so for question 14, we need to prove using algebra that n plus 1 cubed minus n cubed is odd for all n values where n are the natural numbers, and this is for 4 marks. Okay, so this is a proof by deduction question. Now, really quick, this n here essentially means that n is a positive integer. So, for example, n could be 1, 2, 3, 4, and then so forth. So all of these inputs for n, when you put it into n plus 1 cubed minus n cubed, this is odd. Okay, now in this video, in the description, I'll include the mark scheme for this paper. The reason is because there is actually quite a few ways that you can approach this question, and if I do it a different way to the way that you're thinking, I'd really implore you to look at the mark scheme and see if it suggests that way as well. There's a few ways that you can approach this question. The easiest way, in my opinion, is to break n into 2 different possibilities. So if n is any positive integer, that means that n is either even or odd. And what we can do with this is we can prove that this n plus 1 cubed minus n cubed is odd for these 2 possibilities. We'll prove it individually, and then therefore we've proved it overall. Okay, so if we start with n is even, and the way that we can do this is we can say that n is equal to 2k, where k is any positive integer. The reason for this is if k is any positive integer, it doesn't matter if it's even or odd. If you multiply it by 2, it's going to be even, so therefore 2k is going to be an even number. Okay, so n is represented by this. So if we sub this into this here, it's going to be 2k plus 1 to the power of 3 minus 2k to the power of 3, like this here. Okay, so if we simplify this, so firstly, let's expand this 2k plus 1 to the power of 3. Now, you could do this binomially. I think it's slightly quicker to just do it via expanding brackets. So this here, so firstly, this 2k plus 1 times 2k plus 1, this is going to be equal to 4k squared plus 4k plus 1, and this is times 2k plus 1, like this here. And then we can simplify this further. So if we multiply all the terms in this bracket here by 2k, it's going to be 8k cubed plus 8k squared plus 2k, and then if we multiply all the terms in this bracket by 1, it's going to be 4k squared plus 4k plus 1, and then we can simplify this. So we have 8k cubed, we have 8k squared plus 4k squared, which is going to be 12k squared. We have 2k plus 4k, which is going to be 6k, and then we have this plus 1 on the end. So if we sub this into this here, it's going to be 8k cubed plus 12k squared plus 6k plus 1, and then it's minus this 2k cubed, which is going to be 8k cubed. This 8k cubed will cancel out of this minus 8k cubed to just leave us with 12k squared plus 6k plus 1. So we need to prove that this is odd. And the way that we can do this is if we factorize out 2 from this 12k squared plus 6k, so it's going to be 2 6k squared plus 3k, and then we'll leave this plus 1 on the end like this. This is going to be odd. The reason for this is 2 times 6k squared plus 3k is going to be even. The reason for this is this 6k squared plus 3k, it doesn't matter what this is, if it's even or odd. The same logic as before, if we multiply it by 2, it's going to be an even number. So therefore this here is even. So therefore 2 6k squared plus 3k plus 1, this is going to be odd, because if you add 1 to any even number, it's going to become odd. So therefore we've proven that this here is going to be odd. So we've proven it for the even case. So now we just need to prove it for the odd case here. So if we say that n is odd, So we can represent this by n is equal to 2k plus 1. The reason for this is because 2k is going to be even, so if we add 1 to it, it's going to be odd. Now this is the one that I would normally use. However, you actually find that if you use 2k minus 1 in this particular instance, it's actually easier because it simplifies down nicer when you sub it into this here. The reason for this is if we sub it in, so it's going to be n plus 1, so it's going to be 2k minus 1 and then plus 1 to the power of 3, and then this is minus n cubes. This is going to be 2k minus 1 cubed, like this here. This minus 1 will cancel out this plus 1, so we're left with 2k cubed here, and then minus this 2k minus 1 to the power of 3. So this is simplified down nicer here. So we only have one bracket to expand. So if we expand this 2k minus 1, 2k minus 1, 2k minus 1. I'll go through this really quickly because this is essentially the same logic as before. So this would be 4k squared minus 4k plus 1 multiplied by 2k minus 1. And if we expand this, it's going to be 8k cubed minus 8k squared plus 2k. And then if we multiply it by this minus 1, it's going to be minus 4k squared plus 4k minus 1. And then we can simplify this, because we have 8k cubed, we have minus 8k squared minus 4k squared, which is equal to minus 12k squared, and then 2k plus 4k is 6k, and then we have this minus 1 on the end. So if we sub it into this here, it's going to be this 2k cubed minus, and then this bracket here, so the 8k cubed minus 12k squared plus 6k minus 1. Okay, so 2k to the power of 3 is going to be 8k cubed, and then this is going to be minus, if we expand this bracket here, 8k cubed, and then plus 12k squared, then minus 6k, and then plus 1. This 8k cubed will cancel out this 8k cubed to leave us with 12k squared minus 6k plus 1. And then essentially we're going to do the exact same thing as before. So if we factor out 2 here, it's going to be 6k squared minus 3k plus 1. So 6k squared minus 3k is even. So therefore 6k squared minus 3k plus 1 is odd. Okay, so we've proven it for the odd case as well. So as we've proven it for both even or odd, remember for proof you need to write a statement at the end. So we have proven that n plus 1 to the power of 3 minus n cubed is odds when n is either even or odd, and as these are the two possibilities where n is even or odd, therefore we've proven it overall. So therefore n plus 1 cubed minus n cubed is odds when n is the natural numbers, and this here is the final answer. In order to get the 2 marks here, you get 2 marks for proving the even case, and you get 2 marks for proving the odd case. Okay, so this is the final question, question 15. It's a really long question, so I've shown the entire thing here in case you want to have a go at it beforehand. But for part A, we're told about a curve that has this equation here, and we need to show that f dash of x is equal to this here, and this is for 5 marks, so we need to differentiate this here. Now I'll be honest, I think this is by far the most difficult question on this exam, especially to get all 5 marks and to rearrange it into this format here. So what we need to do, we need to differentiate this function here. Now, as this is a fraction, the easiest way to do this is to use the quotient rule. Now, I've given you the formula here for the quotient rule because it's given to you in the formula booklet. So it's d over dx of this f of x over g of x, where f of x is the function in the numerator and g of x is the function in the denominator. Now, in this question, we're told that this whole function is equal to f of x. So rather than calling kind of two things f of x, just quickly, instead of calling this numerator f of x, we're going to call it h of x. Instead of this being f dash of x, it's going to be h dash of x, and instead of this being f of x, this will be h of x. So we're going to use these functions here. So for this, the function in the numerator, we're going to call this h of x, and the function in the denominator, we're going to call this g of x, and we need to differentiate both of these in to use the quotient rule. So if we start with h of x, so this is the numerator, which is 7x e to the power of x. So if we differentiate this here, it's going to be 7, and then we're going to differentiate this x e to the power of x. Now, to differentiate this, we're going to use the product rule. Now, there's loads of ways that people teach the product rule, and there's different ways that people do it. The way that I taught the product rule is that the product rule is this function differentiated multiplied by this function plus this function differentiated multiplied by this function. So the product rule for this one here is going to be this function differentiated, so x differentiated, which is just 1, multiplied by this function, which is e to the power of x, plus this function differentiated, which is e to the power of x differentiated, which is still just going to be e to the power of x, multiplied by this function, which is x, like this here. And we can simplify this because it's going to be 7, and then 1 times e to the power of x is e to the power of x, and then this here is going to be x e to the power of x. And we can expand this bracket, so it's 7e to the power of x plus 7x e to the power of x, like this here. So this is h dash of x. So therefore g x is going to be the denominator, which is going to be this root e to the power of 3x minus 2. Now remember, when you have a root, you can write this as a power of a half, and when we're differentiating, this is a bit easier. So we're going to say g of x is equal to e to the power of 3x minus 2 to the power of a half. Okay, so to differentiate this, we need to use the chain rule. Now again, there's loads of ways that people teach and do the chain rule, so you can kind of do it your way, but the way that I taught the chain rule, I said that the chain rule is the inner function differentiated multiplied by the outer function differentiated, and in this case the inner function is this e to the power of 3x minus 2, so this is the inner function, and the outer function is this power of a half here. Okay, so if we differentiate this, it's going to be the chain rule, so g dash of x is going to be the inner function differentiated, which is this e to the power of 3x minus 2 differentiated. If you differentiate e to the power of 3x, it's going to be 3e to the power of 3x. When you differentiate minus 2, it's just a constant, so it just goes away. And then this is multiplied by the outer function differentiated, which is this power of a half differentiated. You can think about this like x to the power of a half. When you differentiate this, the half comes down as a coefficient. When we differentiate the outer function, we don't touch the inner function. This is kind of the x, so we just keep this as e to the power of 3x minus 2, like this here. And then if it's to the power of a half, when we differentiate this, it's now going to be to the power of minus a half, like this here. And we can simplify this because we've got 3 times a half, which is going to be 3 over 2 e to the power of 3x, and then it's this e to the power of 3x minus 2 to the power of minus a half. So this is g dash of x. So therefore, the quotient rule here is going to be, it's going to be h dash of x, so hang on, so it's going to be f dash of x is equal to h dash of x, so this is this 7e to the power of x plus 7x e to the power of x, like this here. And then this is multiplied by g of x, which is this e to the power of 3x minus 2 to the power of a half. And then this is minus h of x, which is this 7x e to the power of x, and then this is multiplied by g dash of x, which is this 3 over 2 e to the power of 3x e to the power of 3x minus 2 to the power of minus a half. And all of this is over gx squared. So gx is this here. So it's going to be this e to the power of 3x minus 2 to the power of a half, and it's going to be this here squared. Okay, so we've got f dash of x is equal to this here, and now we need to show that it can be written as this here. Now this, I think, is the really hard part of this question in order to simplify it into this format here. A bit of advice that I would have for a question like this is when you're doing a question like this, rather than kind of just randomly going at this and trying to simplify it, I would really recommend looking at what you need here for the final answer and kind of look at the key features that you need to get and see if you can get these in the answer you have at the moment. Okay, so if we look at this f dash of x that we need to get it into, one thing you'll notice that factorized out of the numerator, we have this 7e to the power of x. So can we do this for this numerator here? Now in this numerator we have two terms. We have this term minus this term here. Okay, so to factor out, so we're trying to factor out 7e to the power of x. Well, in this term we can see that this is easy because we have this 7 and then this e to the power of x, so we can factor this out easy. If we look at this term here, if we look at this bracket, we have this 7e to the power of x plus 7xe to the power of x. You can see that we can factor out 7e to the power of x from this as well. So if we do this, it's going to be f dash of x is equal to, so if we factor out 7e to the power of x from this numerator, so this bracket here, if we factor out 7e to the power of x, this is just going to be 1, and then if we factor out 7e to the power of x from this 7xe to the power of x, this is just going to be x, like this here, and then this is multiplied by this other bracket, this e to the power of 3x minus 2 to the power of a half, and then this is minus this term here, and we have this 7x e to the power of x. So if we factor this out, we're just going to be left with x here, multiplied by this 3 over 2 e to the power of 3x. So this is going to be 3 over 2 x e to the power of 3x, then e to the power of 3x minus 2 to the power of minus a half, and then we have a bracket at the end here as well, because all of this is multiplied by 7e to the power of x, and all of this is over the denominator, this e to the power of 3x minus 2 to the power of a half to the power of 2. So this power of a half will cancel out with this power of 2 to just leave us with e to the power of 3x minus 2, like this is. So we factored out the 7e to the power of x. Now if we look at our final answer that we need here, another feature is in the denominator here, if we just ignore this 2 for now, we have this e to the power of 3x minus 2 to the power of 3 over 2. At the moment, we just have e to the power of 3x minus 2. You can think about this as e to the power of 3x minus 2 to the power of 1 if you want. We need this to be to the power of 3 over 2. Now if you look at the numerator, we have this e to the power of 3x minus 2 to the power of minus a half. If we could bring this into the denominator, this would give us this to the power of 3 over 2. So let's try and factorize this out of this numerator here. So it's going to be f dash of x is equal to 7e to the power of x, and then let's try and factorize out this e to the power 3x minus 2 to the power of minus a half, and we can hope that we can bring this into the denominator. Okay, so if we do this, so this term here is easy, this will just factorize out this e to the power of 3x minus 2 to the power of minus half and leave us with this 3 over 2x e to the power of 3x. If we look at this term here, we have this e to the power of 3x minus 2 to the power of a half. If we factorize out e to the power of 3x minus 2 to the power of minus a half, this will just leave us with e to the power of 3x minus 2 to the power of 1. So we can therefore write this as 1 plus x, because we still have this 1 plus x here, and this will now be e to the power of 3x minus 2 to the power of 1, but we don't need to write the power of 1 here. So we simplified this, and then we talked about this part is easy. This will now just be 3 over 2 x e to the power of 3x, like this here, and we factorized out this e to the power of 3x minus 2 to the power of minus a half, and all of this is over e to the power of 3x minus 2. So if we bring this e to the power of 3x minus 2 to the power of minus a half into the denominator, it would be f dash of x is equal to 7e to the power of x, and then it's going to be 1 plus x e to the power of 3x minus 2 minus 3 over 2x e to the power of 3x, and all of this is over e to the power of 3x minus 2 to the power of 3 over 2. Okay, so if we expand this bracket here, we get f dash of x is equal to 7e to the power of x, and then it's going to be e to the power of 3x plus x e to the power of 3x minus 2 minus 2x, and then at the end we've still got this minus 3 over 2x e to the power of 3x, and all of this is over e to the power of 3x minus 2 to the power of 3 over 2. Okay, now we can simplify this here, because you can write this as f dash of x is equal to 7e to the power of x e to the power of 3x. Now here we have x e to the power of 3x minus 3 over 2 x e to the power of 3x, so we can write this as minus a half x e to the power of 3x minus 2x, and all of this is over e to the power of 3x minus 2 to the power of 3 over 2. Now if we look at what we need in the final answer, in this numerator we have factorized out e to the power of 3x. Now you can see here that we have e to the power of 3x minus half x e to the power of 3x. So we can factorize this out. Right, this is f dash of x is equal to 7e to the power of x, and then if we factorize out e to the power of 3x, this is going to be 1 minus half x minus 2x over e to the power of 3x minus 2 to the power of 3 over 2. Now, if you look at what we need in the final answer, this is very, very close. The only difference is that in this bracket we have 2 minus x, and in the denominator we have 2 here. At the moment, in the bracket we have 1 minus a half x, and we don't have this 2 in the denominator. So what we could do here is we could try and factorize out a half from this numerator here, and then bring this half in the denominator to make 2. So we could say that f dash of x is equal to 7e to the power of x multiplied by, and then if we factorize out a half from this here, it will be e to the power of 3x. If we factorize out a half from this, it will become 2 minus x, and then we need to factorize out half from these two terms here, so this will become minus 4 minus 4x, and all of this is over e to the power of 3x minus 2 to the power of 3 over 2. If we bring this half into the denominator as a 2, we get f dash of x is equal to 7e to the power of x e to the power of 3x 2 minus x minus 4 minus 4x, and all of this is over 2 e to the power of 3x minus 2 to the power of 3 over 2, and this here is what we require here. Okay, so as I said, I think this is the hardest question in the exam, especially to get to this final answer here and doing all this rearranging. However, one thing that I think is quite important context here is this question is worth 5 marks. I think the examiners realise how difficult all this rearranging here is in blue, because to get the 5 marks, you get 2 marks for essentially differentiating h of x here into 7e to the power of x plus 7xe to the power of x. You get another mark for differentiating g of x, and then you get another mark for using the quotient rule here and getting this equation here. You actually only get 1 mark for doing all of this rearranging here and getting it into this format, meaning that if you don't successfully do this rearrangement, which as I said is quite hard, you will still get 4 marks for this question. You get a 4th mark for just using the quotient rule here. Okay, so for part B, we need to show that the x-coordinates of the turning points of the curve are solutions of this equation here, and this is worth 2 marks. Okay, so this is to do with iteration, which I haven't actually, Year 2, Chapter 10 is the only chapter I haven't released videos on yet, but I'll still go through the question. So remember, turning points exist when f dash of x is equal to 0. So what we're going to do, this equation here, this f dash of x that we figured out in part A, we're going to set this f dash of x equal to 0 and rearrange it into this format here. Okay, so if we do this, so this is the equation that we made here. So it's going to be 7e to the power of x, and then e to the power of 3x, 2 minus x minus 4 minus 4x over 2e to the power of 3x minus 2 to the power of 3 over 2. This is f dash of x, and this is equal to 0. I'm going to rearrange it in order to get the equation up there. So what we can do, so firstly, let's multiply everything by this 2e to the power of 3x minus 2 to the power of 3 over 2 denominator in order to get rid of this denominator here. It's not really that important. We can do this because we are told that x is bigger than the natural log of this cube root of 2. I won't go through it, but that essentially means that this here cannot be equal to 0, this denominator, so therefore we can multiply everything by it. So therefore, if we multiply everything by it, it'll be 7e to the power of x, e to the power of 3x, 2 minus x minus 4 minus 4x is equal to 0. Let's divide everything by 7e to the power of x. 7e to the power of x cannot be equal to 0, so there's no risk of us dividing by 0. So this is going to be e to the power of 3x 2 minus x minus 4 minus 4x is equal to 0. Let's expand this bracket here, so it's going to become 2e to the power of 3x minus x e to the power of 3x minus 4x is equal to 0. Now, if we look at what we need as a final answer, we need x on this side and all the e to the power of 3x terms on this side. So we have x here in this x e to the power of 3x and x here in this minus 4x. Let's bring both of these onto the other side of the equation. So it's going to be 2e to the power of 3x minus 4 is equal to x e to the power of 3x plus 4x. Let's factorize out x from this here. So this is going to be 2e to the power of 3x minus 4 is equal to x e to the power of 3x plus 4, like this here, and then divide both sides by e to the power of 3x plus 4. So we get that 2e to the power of 3x minus 4 over e to the power of 3x plus 4 is equal to x, and this is what's required. In terms of the marks, I think you get 1 mark for getting it into this format here, and then the second mark for this one. Okay, so for part C, we're told that the equation which we found in part B has 2 positive roots, alpha and beta, where beta is bigger than alpha, and we're going to use this iteration formula in order to find an approximation for alpha and beta. So we're talking about diagram 1 that shows plot of part of the curve of equation y is equal to this equation here that we found, and part of the line of equation y is equal to x. So we need to use this diagram 1 to draw a staircase diagram to show that the iteration formula starting with x1 equal to 1 can be used to find an approximation for beta. And this is for 1 mark. So let's go to this diagram here, which is this, and it's quite important that x1 is equal to 1, and we're shown kind of x is equal to 1 here. Now, as I said, I haven't made videos on this chapter yet. I'd advise looking at the textbook of how to draw a staircase diagram. It's quite easy. Essentially what we do is we start at x is equal to 1 and we go up to the curve here, and then we go horizontal to the line y is equal to x, and then we go up like this, and then we go up like this, and up like this, and up like this, and that's essentially how kind of iteration works with a staircase diagram like this here, and we converge to the value of beta here. Okay, and then for part D, we need to use the iteration formula with x1 is equal to 1 to find three decimal places for the first part, the value of x2, and for the second part, the value of beta, and this is for 3 marks. So we're going to use this iteration formula here. So we are told that x1 is equal to 1. So therefore x2 is going to be, so we're going to plug x is equal to 1 into the iteration formula. So it's going to be 2e to the power of 3, and then instead of x it's 1 and then minus 4, and this is over e to the power of 3x, but instead of x it's 1 like this here, and then plus 4. And if you put this into your calculator to 3 decimal places, it's equal to 1.502. So this is the value of x2. Now to get the value of beta, the best way to do this in my opinion is on your calculator put in this 2e to the power of 3x minus 4 over e to the power of 3x plus 4, but instead of x put the answer symbol like this here, and then what you can do, if you just press equals, it will plug in this 1.502 into the iteration formula as x, and that will give you x3, and then if you press equals again, it will put in that value that you just got out into the iteration formula to give you x4. Then you press equals again, you get x5, and then so on. And what you're going to do, you're going to keep doing this until the value that you get out to 3 decimal places doesn't change. It doesn't matter how many more times you press equals, it converges to the same value to 3 decimal places. And what you find if you keep doing this, you'll find that x7 is equal to 1.968 to 3 decimal places, and it doesn't matter how many more times you press equals, x8, x9, x10 and so on, they are all still equal to 1.968. So therefore beta to 3 decimal places is 1.968, and that's the value of beta. To get the 3 marks here, you get 1 mark for doing this equation here, you get another mark for getting x2 is equal to 1.502, and you get another mark for getting beta here. Okay, and then for part E, we need to use a suitable interval and a suitable function to show that alpha is equal to 0.432 to 3 decimal places for 2 marks. Now, even though this is only worth 2 marks, I think this is actually a really difficult question because you need to kind of fundamentally understand how iteration works, okay? So let's just put this question into context. So we're told that the equation x is equal to this here has two positive roots, alpha and beta. So what this means is alpha and beta are solutions to this equation here. Now, for part D, we approximated beta to 3 decimal places using iteration. We cannot do this for alpha. The reason for this is if you look at a staircase diagram. So for this, we showed how the iteration works with beta. So we start, x1 is equal to 1. We start here, we go up, we hit the curve, we go across, we hit the line, we go up, hit the curve, and so on. And we get this staircase effect. This doesn't work for alpha. The reason for this is if we look at this diagram, so here we have alpha. So in order to use iteration here, we have to find a value before alpha. So let's use this value here. So what will happen if we're using iteration? So this will go up and it will hit the curve here, and then it will go across and hit the line. However, it can't hit the line because the line, the straight line, is up here. So we do not get this staircase effect like we do for beta. This essentially just diverges and we don't get this staircase effect. So this iteration method doesn't work for alpha. So to find alpha to 3 decimal places, we have to use a different method. Now again, the alpha is a solution to this equation here. So we just write this out quickly. So x is equal to 2e to the power of 3x minus 4 over e to the power of 3x plus 4. Alpha is equal to 0.432 to 3 decimal places. This is quite important as we'll come on to in a moment. This is a solution to this equation. So what can we do with this? So what we're going to do, this x, we're going to move this to the other side. So we get 2e to the power of 3x minus 4 over e to the power of 3x plus 4 minus x is equal to 0. This here, a solution to this will still be alpha is equal to 0.432 to 3 decimal places, because this is just the same equation, we've just moved the x to the other side. So alpha here is still a solution. So this here is equal to 0. If we draw a diagram to show what's going on here, so this is y, and this is x. So the graph will look something like this here, where this is where y is equal to 0, it crosses the x-axis, and this here is at alpha, and alpha is 0.432 to 3 decimal places. Okay, now the way that we can prove that this is 0.432 to 3 decimal places is using this idea of how the sign changes when we're locating roots. Okay, so remember, if we take a point, let's say here, and a point here, this, if we sub this into this equation here, this x value, this will be a positive value, and if we sub this x value into this equation, this will be a negative value, or vice versa. Either this could be negative and this could be positive. The point being is around this point we would get a sign change, and this proves that there is a root between these two values here. If we're trying to prove that alpha is equal to 0.432 to 3 decimal places, what we can do is we can prove that alpha is between 0.4315 and 0.4325. If we prove that alpha is in this interval here to 3 decimal places, alpha is equal to 0.432. So what we can do is this point here we can say is 0.4315. We can say that x is equal to 0.4315, and this point here we can say that x is equal to 0.4325. So if we sub these values into this equation here, so if we start with 0.4315, so it will be 2e to the power of 3, and then this 0.4315, then minus 4, and this is over e to the power of 3, and then this 0.4315 plus 4. So we're using this equation here, so we're also going to minus x from this, so minus 0.4315. If you put this into your calculator, you get out a value of minus 2.9747 times 10 to the power of minus 4. So this here is negative. If you do the exact same thing for 0.4325, I won't write it out because it's quite long, but essentially you sub in 0.4325 for x. If you do this, you get out a value of 9.4795 times 10 to the minus 4, and this here is positive. So we can see that between 0.4315 and 0.4325 there is a sign change. It goes from negative to positive. So therefore somewhere in between this is equal to 0, and therefore this root, which is alpha, is this here. So what we can do is we can say, as there's, let me just scroll that out, as there's a sign change between x is equal to 0.4315 and x is equal to 0.4325, therefore alpha is equal to 0.432 to 3 decimal places, and then this here would get you the marks.